La lucina del mio microfono è verde, poi spero che sia connesso e tutto.
Okay, so welcome everyone. As a reminder, for this talk there will be a Q&A session and you can ask your question on Slido. And you can find Slido on pycon.it/Slido and find the room which is Gnocchi. So it's a real pleasure to have here on stage Domenico. Domenico is part of our Python Milan community, and he is a software engineer, independent contractor, and as he likes to tell me, he is a mercenary. He will work for you if you pay him. And he's had fun with AST, standard modules part of the standard library, and he will tell us all about it. It is also the first time he's doing a talk at a conference, so give him a big round of applause for Domenico.
Thank you very much. I'm going to talk to you about the AST, the standard module of Python. A little bit of backstory. I discovered it here, like not here, but in Florence 2 years ago during a lunch break. I was just speaking with some guru programmer. He told me, like, yeah, you should try it for one of my personal projects. And I tried it. It was a really, really good library. It helped me a lot. And sometimes it even turns out to be useful at work. So it's, I mean, I'm using it since 2 years in several different projects scattered because, I mean, every time you have to do with Python code, this can help you. This helps me. So a little bit of the agenda. I would like to motivate, talk about like why it could make sense to talk about the AST standard library. Then I would like to talk about the tree, its nodes. I think that it is boring to mention the nodes, but they are important because in the second part, when we talk about walking the tree, when we talk about the AST and how we traverse it, the nodes are very important for the API, so knowing them can help you. Then hoping some demo, showing some code running, and then maybe some conclusions. So, okay. Let's imagine that you have to process some Python code. Okay, today, no, you do not have to connect to a DB, you do not have to open a CSV. No, the raw input today for you, you wake up and no, you have to process Python code. It's a string, and so what can you do? You can use regular expressions. It makes a lot of sense. Some people may laugh because, I don't know if you laugh because of Per, love the guy. Regular expressions, however, they are pretty much a good choice. And I mean, I advocate for them, they are good. Or you can start to write your own stuff. You can start to say, okay, read lines. If def is in line, okay, I have a function, and that stuff. Yeah, you can write your own stuff. Or you can give your code in input to an LLM, and the LLM will do stuff for you. All of these approaches, they are actually good. I'm not here to advocate against any of them, but actually you are managing a string. So you are still in the string manipulation phase. It's as if you were to open a CSV, and okay, you open the string, and you start to split by comma. But no, you're managing a string. Nobody does that. We just import pandas, we import polars, and we read the CSV. We use a parser for this. And then we have a data structure, we have the data frame. So what if we have to process Python code, and we just have a data structure that represents our Python code? We just have these, well, at the end of the day, it's the abstract syntax tree. You just have this abstract syntax tree, you explore it, you play with that, but you don't have to manipulate a string. Just, I mean, AST did that for you. As a final round of motivation, there are a lot of very cool people that do very cool stuff with AST. For example, on the PsychoPG3 blog, there is a blog post in which they say that they don't write the synchronous code for PsychoPG3. They write the asynchronous code, and then there is a snippet powered by AST. They use AST to write automatically the synchronous code. Also, I mean, I don't know if you heard of, I spoke with Antonio Cuni, the guy who was talking about SPY yesterday, and he uses AST. So behind a lot of very, very cool projects, this library is there. So I mean, it's cool, it's useful. And at this point, you may be wondering, okay, but how do you obtain this abstract syntax tree? That's the cool thing. It's super easy. AST is in the standard because Python, I mean, it needs the abstract syntax tree to run, so it's there. But it gets exposed. There is this AST library, which is basically, how to say, a kind of wrapper around already the internal CPython stuff that allows you to access it directly through Python. So you can just import AST, say ast.parse, feed it in input your code, and bang, you're there. You have the abstract syntax tree. From here, you can play and do whatever you want. In this case, we want to have the abstract syntax tree of hello world, and we use dump. Dump is like JSON dumps, you get the string representation of the abstract syntax tree. And so in this case, what do we have? A module, because, we fed it in input a module with just one code line. It will have a body, which will have an expression, which is a call, because we are calling a function, and the call, well, it has a name, which is print. It could be also something like, yeah, you have a dictionary of strings, of dictionary of functions, and you access it. But in this case, it's just a name, it's print, and you are feeding in it a constant, because we basically like hard wrote in the code, okay, hello world. And that is like our abstract syntax tree. It's a module with a call, with a name, and the argument is a constant. And so what you may be, like, just to, I mean, I don't know if you already have, like, if you, any of you ever, like, I forgot about the thing, like, just for me to get an idea. How many of us have ever, like, ever played with the abstract syntax tree library in Python? Okay, some of us. In other languages? Okay, a good portion of us. If you're like me, like 2 years ago, it was the first time I came across an abstract syntax tree, okay, there are nodes of different types. And actually, the whole idea is that you can kind of like think, okay, for every grammatical expression inside Python, there is a corresponding AST node type. And this gives rise to a thing that, I mean, I wouldn't say that polymorphic is the right way to describe this tree, but the abstract syntax tree is different from maybe like the common binary tree that you have in your brain, because, I mean, a binary tree, every node is of the same type. Every node has a left child and a right child, and they are just all the same. No, in abstract syntax tree, you will have a module. The module has a body, and inside the body, there are all of the other statements. You have an assignment. The assignments will have some targets, some values, and the whole idea is that when you have to play with that, the types of nodes are different, and also their own parent-child relationships, they are different. They depend on the specific grammar construct that you are encountering. So there are nodes of many different types, many different types. Most of them, you come to them with intuition. I mean, you can just like, okay, you can understand what they are, but they have some things in common inside the library. So most of the nodes, they possess their coordinates inside the code. They have a line number, an end line number, a column offset, so that you can basically say, okay, this node was located in this portion of the code if you maintain your original string. And also at the same time, like function, classes, loops, like every time you kind of like have to have a tab indentation, you unlock a body attribute, which will be then the list of the substatements of your node. So let's say that you have a function definition. The function will have a body. In this case, the body will contain a pair of assignments, a for loop, and then a return. Inside the for loop, there is going to be another body, which is its own body with its own, in this case, a couple of augmented assignments. Just one thing that I would have liked to tell myself, like 2 years ago, there are not just bodies. So for example, a try-catch has handlers, and like maybe the for loop will have an or else. In this case, the or else will be just an empty list or none, but body, you will encounter it in many places, but maybe, okay, now you come up to an if may have an else, and the else will be represented as an attribute. So when you want to iterate over them, just be careful. Be careful, because there are some other attributes rather than just body. And then, okay, I will show you some example of nodes. I guess that this is boring, but as I said, when we encounter visitors and transformers, like the APIs of the AST kind of like use the node names to allow you to get, to call callbacks and whatever. So at the end of the day, they will turn out to be useful, again, later. So for example, you define a class, and every time you define a class in your code, in the abstract syntax tree, there will be a corresponding ast.classDef node. You define a function, okay, this is an ast.functionDef. A return statement, I mean, return is an element of the Python grammar. There is a corresponding ast.return node type inside the ast. Print is a call, so you're calling something, you're invoking a call, okay, this is a node of type call. There are nodes for the basic data structures, so you're defining a list. There will be a node for the native list. There are also nodes for the data structures comprehensions. And, well, it's kind of like mostly intuitive, I hope, up to this point. But I would like to tell you some subtleties, because I discovered them in not the bad way, but I mean, I would have liked somebody to tell me those things in advance. First thing that you can basically, like, how to say, kind of like expect. If you forget about the existence of import lib and other evil stuff, like you can maybe like import things in Python into different ways. Import JSON, from JSON import loads. Okay. These things map to 2 different types of nodes. That is important, because let's say that at a certain point you're like, oh, okay, I'm analyzing this code. What is it importing? When you want to do that, you want to keep track of 2 different types of nodes. functions, everything asynchronous has its own kind of like corresponding counterpart. So let's say that you are interested in, say, oh, I want to see all the functions inside my code. If you just take a look at nodes of type ast.functionDef, you are going to miss all of the node types, all of your asynchronous functions. And the most thing ever, those are assignments. So you may think, okay, in this case, I'm just assigning, if I want to keep track of all the assignments inside my function, okay, I just need to take a look at ast.assign because it is an assignment. No. Annotations, they map to a completely different type of node, which is ast.unassign, which makes also a lot of sense from the grammar standpoint because you can say foo equal bar equal 1, in such case, both foo and bar gets targeted by the assignment. In an annotated assignment, you cannot do that. Also, if you take a look at the attributes of these two classes, because after all, we were just talking about classes, and they will have attributes, they are different. For us, for ast.assign, you have a list. For ast.unassign, you just have one specific target, which is the specific variable that you are performing an assignment on. Also, one thing that I never got to try to play, but I was taking a look, there is an ast.try star in the official documentation. So I warn you, if you ever are interested in tracking down your try statements, just be careful at try star. One cool thing, there are type annotations. As far as I know, the abstract syntax tree treats type annotations the same way that Python does. It basically ignores them, but it reports them to you. So if you want to say, okay, just a function def, what is its returns type? It has a returns attribute, which is the actual type annotation. And they are scattered. Also, the AST, that annotated annotation, will have all of the, will basically allow you to find again all of the type hinting that you are putting inside your code. It's there. You have it with you. So, arrived at this point. I hope that that thing did not bore you too much. We arrived at like the maybe like funnier part when we can like traverse our tree. And in doing it is like super easy because AST comes equipped with a lot of support functionalities rather than only the actual syntax tree. You get to have a lot of things that allow you to play with it. And if you want to iterate all over all the descendants of either your abstract syntax tree or maybe just a subnode, you just need to invoke est.walk. It's a function, you give it a node, and then it will iterate through all of the children. It does so in no particular order, so it is unordered. And to give you an idea of how it works, what it does, I tried to prepare this kind of like little game. I hope this is accessible and you can basically distinguish the different colors. But this is basically just a stupid Fibonacci that I wrote. And in the higher part, there is not the code. There is just an indication that tells you like the node number, the line when it happens, and actually the class, the type class. What I'm basically doing is taking the output of ast.walk and store it in a list under the hood, which basically means that we are actually taking a look, we will take a look at the ordered nodes that come in an unordered way out of walk. Basically, walk starts from the shallowest nodes in your abstract syntax tree. The root is the ast.module, and basically descends up into the down into the deepest ones. So in this case, like the first node that you actually meet in your module is when you walk it, is the actual function def Fibonacci. Next node will be starting from the shallowest, the next if inside your code in the module, which is the if name equal main. Going further, we will encounter like the first child of first node that we saw of the first node of the like first level of depth over tree. So we will basically encounter the first if comprised with its else. And I mean, like I like to play with it, go on and go further. And but I would like to stop at this point and showcase you that like walk will also like take all of the say intermediate expressions inside your code. That is like the cool thing about the abstract syntax tree. It doesn't just take a look at your code lines. It takes a look at all of the expressions. And up to this point, since we are basically just running through the output of walk, we encounter, like, for example, in this case, a Boolean operation, that it is like the 7th node that we actually have, but the index started from 0, so it was the 8th. And we have a Boolean operation, which will have two children, I = 0, I = 1. And maybe we are asking ourselves, okay, but these specific comparison nodes, when are we going to see them? The answer that I always like to say is, as you understood, walk will be unordered, so we will first have to go through all of the other children of the parent of that poor Boolean operation. At a certain point, at the 16th node, if I remember well, we will finally encounter our compare. And the 17th node, actually the 18th, because we started from 0, is the I = 1. And this was a very, very stupid game, but I hope that it kind of like got into the mindset of, okay, I'm exploring my tree, and this will be like super, super annoying. And the way in which I iterate through it is kind of like different from the way in which we read our code. Maybe we read our code one line at a time. I read my code one line at a time, human being. That's what I do. So, having gone past through that, the next two super cool things that basically AST provides us are node visitors and node transformers. As you can understand, node visitor basically allows you to just do funny stuff when you just read your own abstract syntax tree. Node transformer basically allows you not only to just read the tree, but to return a modified version of your tree. Node transformer is the kind of like super evil thing that you use when you want to automatically transform your code. So just to like give you some kind of like guide on how this works, node visitor is basically just this class, this abstract class that needs to be kind of like it needs to be a base class. So you need to write a class that inherits from it, and basically it gives you a method which is visit. You can pass it in input tree, or maybe like just a sub node of your tree or whatever, and it will just perform activities every time it encounters a node for which you defined a function which is visit underscore and the name of the node. That's why the name of the nodes were super, super important, because basically the APIs of AST require you to know the name of the node, and they perform specific activities on specific types. So in this case, what are we doing? We just developed a stupid node visitor in which basically says, okay, every time you encounter a function def, it has the signature, of course, you need to pass it to itself and the node itself, but the node will be of type function def. Do something with this function definition. In this case, okay, if it has a return annotation, this will just print the name of the function and the ID, basically. Also, a very, very important thing, you actually always need to invoke generic visit if you want the sub-nodes of the node you're actually handling to be also explored by node visitor. Let's say in this case that you want to track nested function definition, like you define a function, then you define a function inside the function. If you don't write self-generic visit, you are going to miss all of the children function, all of the sub-functions that are nested inside the first function that gets encountered. This is just to say that thing to you. And once we saw node visitor, the next cool thing is node transformer. Node transformer basically allows you to take your abstract syntax tree, and every time you define one of its callbacks, you can basically tell him the node that it needs to return, which can be the same node, but it can also be the node modified or a completely different node. In this case, we have this node transformer. We'll just okay, say visit tree and then reassign the tree. In this case, every time we go through a list comprehension, of course we do the self-generic visit in order to take like nested list comprehensions, but basically we are returning a set comprehension instead of the list comprehension with the same internal attributes of the node. So this is like the same list comprehension, the same thing, but this time it is a set comprehension. Why are we interested in doing this? Boy, I have no idea, but I mean, it could have been fun. Other helpers before the demo, you can have like a lot of like other support functionalities inside AST. If you are interested in taking a look at the source code of a node, there is a function for it, get search segment. There is a get docstring, which basically allows you only for, if I remember well, classes definition, function definitions, and hopefully I also think assign function definitions. It will give you the docstring of your node. It is easy to access it. You can iterate through the child node, through the children of a specific node. You can print the AST, as I was showing you before, and there is also super cool unparse. Unparse allows you to take an abstract syntax tree, you modified it, you did whatever you wanted to do, and you can regenerate the code. Sometimes this is actually easy. I mean, sometimes when I want to generate some Python code, actually like string formatting has some limits, because maybe it happens that they need to generate like code section 1, and that code section 2 depends still on code section 1, so I don't want to just reparse it again. You can basically just generate your Python code by building an abstract syntax tree and then just feed it into unparse. You can do that. So, arriving at this point, I hope that you are all like ready and everything. There is a demo. So, I hope that you can basically just see the code, that the character size is enough. I thought about something dumb. Let's just take a code base. In this case, I just cloned Pydantic. I don't know which version of Pydantic. I did it some time ago. And my idea was like, OK, let's iterate through all of the files of Pydantic and collect some stupid data about Pydantic, about its stuff. So for example, just to showcase you the code, the main loop, we are just iterating throughout all the files from our root folder. We then take the code. We then parse the code so that we obtain for every file its module. And then, well, I just wanted my node visitor to just always have an updated file path and the updated code so that I can play with that while I go through the nodes. And then, OK, I just visit it. From there, well, I defined a node visitor because I wanted to collect some stupid data out of Pydantic. And basically, OK, I initialize it with some stuff that I'm going to fill in. And I have the set file method. But just the first thing that I wanted to do was like, OK, let's just scrape some function data. And basically, OK, if I want to do this, node visitor, I just overload function def, visit function def. And OK, I can just create a set of function names. I can get the docstring. And then since I wanted to build a data frame, I can basically just build a list of dictionaries, which will be then converted inside the data frame to just have the function name, line number, the number of lines, the number of characters. I can easily take the number of characters by taking the length of the search segment, because there is an IST helper to get the search segment. And I can basically just then plot some stuff out of that. Which, if we run it, I just set a lot of other things to false, because I didn't want to have any other prints. Just to give you an idea, if we want to take some data out of the whole code base, I then just need to run this. And once this thing basically just unrolls and goes through like all the files and all the functions inside Pydantic, I want to say, OK, let's have a scatter plot with, on the x-axis, I hope that you get to read this, the number of code lines, and on the y-axis, the number of characters. I was interested, like, are they correlated? And then I have to say, yes, they are correlated. Next funny thing that you can do with not much effort, honestly, you can just build your own distribution plot of the number of code lines inside every function of Pydantic. This is kind of like doable. The next thing that I wanted to, that I was kind of like curious, it is a stupid question, but I was curious. Does Pydantic use data class? Is there anybody who is here is interested in like knowing if Pydantic, which basically gives another, just kind of like say an alternative to data class, inside Pydantic are data classes used? OK, let's take a look at it. We just have, my idea was like, OK, let's visit all the class definitions. And the first part is to just take a look at the callables. We are not interested in this, not now. But then if we want to check where are all the data class, OK, I need to basically take a look at the decorator list of my class. Then I just take the ones which are not called, just names. And I just say, OK, if inside the decorator ID, inside the node ID of my data class, of the data class decorator, of my decorator, there is the data class string, OK, let's just print it. And if we run it, we'll basically see that there are some cases inside Pydantic. I will just zoom in a moment, where the data class is actually used. There are many, many more, honestly, but there are cases in which data class is actually just, how to say, just invoked through a call and not just through a name. So I have at this point, there are words beyond, like I just kind of like dipped my toes inside AST, but you can do a lot of stuff. IST offers you to compile the bytecode, and there is an ecosystem built around Dust. Finally, some personal opinion from my side. I have to say it is rare, unless you really have a personal project in which you really, really need to just do a lot of parsing, it is rarely useful in my life. But when it is a game changer. Like, it makes you feel like an ex-developer because you can do like pretty much crazy, crazy stuff. Also at your job, things like, oh my God, we need this type of thing, it will take 1 month. No, 2 days, AST. So if you think it could serve it to you, I mean, you saw it's in the standard, it's there, 10 characters, you can import it, and it's useful. Links to the resources, there is, OK, the official docs. Green Tree Snakes is kind of like the unofficial docs, and it's super, super useful. There is awesome Python AST, and the memes at the beginning were from Programmers Are Also Human. I love the channel on YouTube. And, well, thank you for the attention.
Thank you, Domenico. Thank you. So there are a couple of questions. You can still add some more questions. The first question is, can you access the parent node in the AST visitor?
The parent node.
Parent.
The parent node in the AST visitor, I fear not. In my humble and super limited knowledge, I still didn't find a way to do that, honestly, because I never ever saw it among the attributes. That's a kind of like limitation, but that also is also like up to my super limited knowledge. I put it in advance, I just have 2 years. So maybe if there is kind of like a guru, he will tell you, oh, okay, there is a hidden way. I just never found it in 2 years that I'm using it.
So this was a question by Florian, and if you want to raise your hand when I say the question so that the speaker can look at you, you are welcome to do so. If you do not want to, you can also be anonymous. There is another question by W3R. Is the AST parse function specific for the Python language, or is it possible to use it with other languages, or even custom structures?
From what I fear, it only works on the Python language, because basically this language, it's not like a parsing library. This is just CPython internals. This is CPython's internals that get exposed. But the abstract syntax tree is not, it's not something only with Python. I mean, it's a theoretical programming concept. So there are abstract syntax tree libraries also for other programming languages. You just have to go take a look at that implementation and take a look at the library. I even have a doubt that PyPy has its own AST, because if you go and take a look, for example, just PyPy, which is another Python implementation, has its own abstract syntax tree. I played with it for one night just to play, and it looks like it's almost the same if you take a look at the beginning, but it's, but how to say, this is not a parsing library. This is an internal thing to make Python work. It just gets exposed.
Okay. Then I have another question. So you use the AST to analyze code and to extract statistics. Have you ever used it to generate code on the fly at runtime and run that code?
No, I never did that kind of heavy stuff. It's the next step. Like probably in this year I will try to do this. It's the next step.
Okay. We have some time if you want to raise your hand and do a question the old style.
Or we can take a look at other like stupid things that could have been done with the AST. I don't know if
you want to have another minute for another demo.
But I will use it. I will waste your life for 1 minute for an additional minute. Like, come on, if we are at this. Hmm? Yeah, come on, let's do. We are all here to Pythonize. So I think one thing that makes like a kind of like this thing useful is actually like okay, because I mean data class you could have done it with a text search, and that's the okay. But let's say that you are interested in saying okay, what are all the callables inside Pydantic? Bang, and you have to do it by string manipulation. Bang, you can look at all the call patterns, and also let's say that, I mean, you have to take a look at everything that it's not inside a comment, but if you want to do that with EST, it's kind of like easy. You just take a look at all of the classes, you then can iterate through all of its elements in the body. I didn't even wanted to use walk. Then okay, if there is a function def, which his name is call, okay, then you know that you have a callable. That is just one stupid code example, but this is one of the situations in which, okay, having a parsed data structure is actually way more helpful than just performing just search on a string. So sometimes it's pretty like a 10x trick importing this library, in my humble opinion.
Okay. Thank you again, Domenico.
Thank you for the attention.
And you can always reach out to him now and have him spread again his enthusiasm for the AST module in private conversation.
Okay.
a G. That is like what makes our accent look like our accent. Like that's how I can tell like a Brazilian speaking English. No, no, they do Thiago, but they don't do Thiago. For us, it's difficult to do Thiago, which would be like the English. Actually, the English would try, because there is a TH, they would try to do Thiago, but yeah, like the sub T and G and D, it's hard for us. We don't have that in our language. Also the TH, which I think we also don't have, right? Yeah, so those are like sounds that we need to learn. So yeah, so Brazilians that have practiced that, maybe they are good enough to don't show, but like the common Brazilian, you can tell like because of those words, you can tell the accent very easily. Almost a full one.
When the signs will be when it's 10 minutes left.
You can.
Okay, so we have a full house, so let's defragment the seatings and sit all closely together so that last-minute joiners can sit. Yes, you can close the door. There used to be a time when Python typing was controversial, and Thiago just confessed me that he used to be a typing hater, but he converted. And so we are now, there's a bunch of people that loves do typing, and we are eager to learn more and to learn advanced technique. So please give a great round of applause to Thiago Bellini Ribeiro for typing your Python code like a ninja. Questions on Slido.
So hello everyone. Can you hear me well? Everyone? Okay, great. So welcome to my talk, typing your Python code like a ninja. I think like it's very obvious what I'm going to talk about. And like starting with about me. So my name is Thiago Bellini Ribeiro. I'm not Italian, I'm actually Brazilian. I have some Italian roots. I'm living currently in the Netherlands where I work. I am also an open source maintainer. I am one of the maintainers of the Strawberry GraphQL library. If you ever have used it, I am one of the devs behind it. And yeah, as I said, I'm working in the Netherlands. I work as a software engineer for the St. Cloud, the company. And I'm a great beer enjoyer. So let's get started. I'm not going to go too much into the basics. I think we are all familiarized with the basics nowadays. But let's just start with a basic example in here. So very simple example. We have a double function, takes an int, makes it times 2, and returns an int get user, takes a primary key, returns the user. So far, so good, right? We can try to extend it to make it so double can actually work with strings as well. Like we can multiply a string. Get user, we can modify it to like make it strict or not. So if the user doesn't exist and it's not strict, we return none. Otherwise, we raise an error. So that means that we can either get a user or none here. And if we try to use it, you can see that if I try to pass like double, I try to pass 10. When I reveal the type, it's a string or int. The same for the user. If I try to do even the strict, I know that I'm always going to get a user. Otherwise, there would be an error. But I still need to narrow this after, because it can be known on the typing. So yeah, that's not bad, but that's not good as well. So how would a ninja solve this? So that's where I introduce overload. And overloads are basically just that. So you have multiple signatures of that same function. Like some other languages actually implement overload in other ways. Python has a single implementation, which is like where you actually define the code, but you can define other signatures. So in this case, the double, when you pass an int to it, you are going to get an int back. If you pass a string, you get a string back. And this is the actual implementation. So yay, now if I pass 10, I get an int. If I pass foo, I get a string back. It's going to be foo. And typing is happy now. That's pretty good, I think. The same for the get user. So I can now tell this is like a little bit more complex, but not that much. So if I pass literally true to the strict, I get a user. If I don't get one, that means an error happened. If I don't pass, and also the default is false, I can get a user or none. And then I can have this. I can do a get user. A get user without strict is going to give me user or none. But if I pass strict, now I am sure that I get a user. I don't need to check, oh, is this none or not? And if I don't get it, I want it to fail. I don't want to have like silent errors. But some of you might have noticed it. There is a way to improve double even further. So that's where I introduce generics. Double, if you have noticed, like it can work with other stuff as well, not only ints or strings. It can work with a decimal. So if I say that I can take a generic typing here, and I'm going to return the same typing here, now I can pass 10, it's an int. When I pass foo, it's a string. When I pass decimal, I get a decimal back. So yeah, that is like we have a lot of power now. But and of course, if you are using Python, I think it's 3.12, 3.13 that introduced this new syntax. I'm sorry, I don't remember correctly, but you don't need to import type var anymore. You can just do this. It's syntactic sugar, but I like it. I think it's cleaner. This way, you say that this function will use a generic t. You say that x receives t and returns the type t as well. But suppose that we still don't want that kind of power to be used. We want to limit it to only strings and ints. So we can define an upper boundary of the type. In this case, t is limited to strings or integers or subclasses of those, not many subclasses of those, but still, you are still going to get the generic working the same way. But now, because of the upper boundary, if you try to use a decimal, for example, the typing will not allow. This is not a runtime issue, but the typing, for some reason, maybe you don't want to have decimal. It's fine, like it's your program. Generics can also be used for classes. So very simple implementation of like a model manager. Suppose that we have a model manager here. This is a generic class. T, in this case, can be a model or a subclass of it. And the init takes a model class, which I store, and then I have a function, which when I call it with a primary key, I get back an instance of t. So if I try to instantiate this, I'm going to get like, a model manager of user. User, is, in this case, is a subclass of model. I get a model manager of user, just like a list of an integer. I would get like a list is a generic container. And if I now want to do a get for in this user manager for the primary key, I got the user back because that is what my function is returning. And we can also have generic callables. Like this is, I think, probably the most complex one that I'm going to show, but like it is actually pretty simple. If you take a look, like ignore for now like the arguments, you have a timing function which takes a function here and returns another function. That's basically it. So the function that it's going to be returning is this inner function, which takes whatever arguments and keywords, and literally prints the time it took to run that function and returns. So it's like it's a decorator pattern, and we can use it like this. So, but without the typing stuff here, by adding timing to complex func, we would lose all the typing information from the original function in here. By capturing the parameters in here and the response value, we say that we receive a function, a callable, with parameters p and response r, and we also return another callable with parameters p and response r. We can manipulate this, use concat to like add extra parameters, do injections. Not going to go through this right now. Like we could have a whole talk about generics only. So yeah. So moving on to another problem now. So let's talk about type narrowing. So another very simple example. We have model and a user which inherits from model. We have a function called process user and a function called process object. Process user takes a user. Process object is generic, and in case it identifies that the object is a user, and this function is doing the check, it's going to call process user. Runtime, great. But can you spot the issue with the typing here? The issue is basically, is user, okay, for is user, when you do is instance, you are narrowing, but in here, the type checkers have no idea that you just narrowed it to be a user. So for the type checker, this is still a model. And if you try to pass a model to process user, it doesn't work because it wants a user. So it's ninja time again. So let's introduce now type guard and type piece. So that's the whole reason why type guard exists. This is a very simple example. Probably you would want to do like his instance directly, but maybe you have a more complex case to check if something is of a given type. And in this case, the type guard can be used as a return value to a function which returns a Boolean, true or false. And when we say that if is user of the object, this gets narrowed because of the type guard, this gets narrowed to user. So inside this, we know the type checker know that this is a user. So we don't have typing errors anymore, like magic. And so you would think, oh yeah, so if I have the same function which takes a user or a ninja, if I do this, this is a user. And the else, this would be ninja, right? Of course, like at runtime, it's actually ninja. But, well, that's not how type guard works. Unfortunately, like that is like there is a history behind it. There is a whole reason why. Not going to go into details, but that is where we have type is, got recently introduced in the language, which behaves the way that most people would expect that type guard should behave. And now the else is actually ninja. So like, I'm always going to say like, if you want to use one or the other, usually you want type is. If you need type guard, you know that you need type guard for some specific reason. Moving on to another topic, so for the kwargs lovers. Again, so let's now try to create a user instance. We define a function here, takes whatever, and calls user.objects.create, like this is Django, let's say, passing all the kwargs. So far, so good, but let's say that username is the required attribute in there. If we do this, okay. If we forget to pass the username, we just pass the first name, runtime error, because, well, username is required. Or if we do this, username is here, but age doesn't exist there, another error. But how can we protect ourselves against that? Because, well, kwargs takes anything. The ninja appears once more, and that's when like we understand that we can use type dicts for this. So on a type dict, we can say, oh, those are the arguments that I take. Username, it's the required one. First name can be given as a string. Last name can be given as a string or none. And we unpack that, that typed dict into kwargs. So now the typing is going to, if I do this, I even get code completions depending on the ID that you are using. If I do this, it's okay, but this is going to be an error because it's going to say, oh, you are missing passing username. If you do this, it's going to say, oh, we don't have an age. So the typing is going to actually help you with that. Of course, in this example, I was using total false, which means like you don't need to pass everything. Everything by default is not required unless you say that it's required. But you can remove this, which would make everything required, and you can use the other way around and do not required for the stuff that is not required. So lastly, let's talk about overrides. Okay. So overrides, this is something like most people don't understand exactly why it exists. It seems like just a fancy thing, but quick example here. So we have a person class. Suppose that this is even coming from a third-party library, which you don't have control over, and you create a ninja, which hopefully is a person. And you want to override how move-to works because, well, ninjas move very differently than normal people. So you do this, okay, great. And if you have a function that takes any person, you can make the person move to some place. Even if it is a ninja, this is going to work. But what happens if the person moves to signature gets changed this way? Again, that's why I said maybe this is coming from another place because you wouldn't know unless you have a unit test for this. Otherwise, you're just going to get a runtime error in this case because now you don't get X and Y anymore. Now you get a tuple of coordinates. So how can we protect ourselves against this runtime error if we pass ninja? So the ninja hits its final blow in this time, and we introduce override. So override is basically, I come here and say, well, when I'm defining move to, I am overriding something that already exists in one of my parents. So that will tell the type checker that please let me know if I am actually overriding something. So if move to gets removed, it's going to say, oh, you are not overriding anything. Don't do that. Or if the signature gets changed in a way that it's incompatible now, it's going to also alert oh, this is incompatible. Also, don't do this. Type checkers are usually now doing this as well, but still override is nice because of if the move to gets removed, you want to know. So yeah, override is more than just a fancy decorator. At first, I thought it was just a fancy decorator. So enough of ninjas now. Let's talk about self. But what self? Myself? Yourself? No, typing self. Okay, it worked. Wasn't sure if it was going to work, but yeah, for that, let's make some pizza. And yeah, so let's make some Italian pizza here. So let's use a builder pattern for this. So to make an Italian pizza, we make dough, we add tomato sauce, we add cheese. I'm not adding everything here just to keep it simple, but if we call this pizza, we instantiate Italian pizza, make the dough, add tomato sauce, add cheese. What we get in the end? Italian pizza. And of course, Ernesto approves this. Who wouldn't? And now I have to give a warning here. Some viewers might find the following image very disturbing. So viewer discretion is advised, highly advised. Let's make now some Hawaiian pizza. And yeah, so what is the deal with the Hawaiian pizza? They will want to add pineapple. And when we try to make the Hawaiian pizza, it's still trying to be made like an Italian pizza. So it will still try to make the dough, add tomato sauce, add cheese, but try to add pineapple after. What is the issue here? If you notice it here, the make dough returns an Italian pizza. So when I do this, make dough, now this object is an Italian pizza. Add tomato sauce, okay, this is going to work. Italian pizza, you can add tomato sauce. Add cheese, it will work. You can add cheese to an Italian pizza. But you don't try to add pineapple to an Italian pizza. It's not going to work. Ernesto totally disapproves this. So, so how can we fix this? And that is where we introduce self, which again, seems like just a fancy way to not repeat yourself with the class name, but if we change this, again, the whole implementation is not here, but I'm changing make dough to self, to return self, and also add pineapple to return self. And now, everything works the way it's supposed to be, still not great pizza, but at least it's not in the Italian one. And I don't have any images for Ernesto for this, but I guess he approves slightly. At least it's not in the Italian pizza, right? And fitting it almost, perfect. So fitting almost all together here, let's just a final example of almost everything that we did, we've learned so far. We have a class Ninja here, which we have a method to move to some place, which can either receive a latitude, longitude, or a location instance. And this would be using the overload. Because we are ninjas, we can clone into another target. The target can be another person or another ninja. And what we get back is the clone of that target, whatever if it is a person, a ninja, or a subclass of one of those. Or we can even hide ourselves, we are ninjas, and we get a hidden instance of ourselves. And that's all that I have for today, folks, and thank you very much. This QR code has, if you want to, it is to download this presentation. I think it's going to be available for yeah, it's going, right? So, but you can download it now if you want. And let's go to QA.
Thank you, Tiago. Thank you. So, this was a great rundown into slides, and you already have answered a question that came up, which was, please share the slides on Discord. There is an additional thing.
On Discord.
Copy and paste.
Okay, I'm going to. I'm going to.
Start typing other questions. I gotta get out of there. I mean, there are so many phones pointed at this thing. You'll get the typing. So there is another question. Somebody probably got convinced that the typing is good, so they're asking, are there good strategies to incrementally add typing to a code base?
Okay, that is a very good question. To be honest, I don't have a proper answer. I know that there are, like, if you are starting with a code base that is not typed at all, there are some type checkers that has like a baseline which you can use. For example, if you are using, let's say, Pyrite, you have a fork of Pyrite, which is based Pyrite, if I'm not mistaken the name. And they have a baseline which they create like a baseline file saying, oh, those are the existing issues. You can't introduce more than those, but during new development, you are going to be removing some of those, but so you can introduce those slowly. I know also Thai, which is like will be soon the new cool kid in town, like from Astral, type check and also language server. From what I've read, it's going to allow you to do incremental application as well. So yeah, I'm looking forward for Thai.
You keep answering questions before I give them to you, because Florian is asking, have you looked at Project Thai by Astral?
Oh yeah, I have. I tried. So far, like, it's pretty good. As you might imagine, it's blazing fast. But there is a lot of still like false positives. I tried using it as a language server in my IDE as well, and like it's missing a lot of stuff. You can't like go to definition. You can't hover. Hopefully, we'll have that soon. But again, like, I'm really hyped about it.
Okay. Now, a question about kwargs, or is it kwargs? I don't know. Why not just list them out in the func method, the definition?
Oh yeah, no, of course. Preferably, that's how you say it. I'm sorry, I don't know. But you want to do that. But there are cases where you need kwargs for some reason, and when you do, that's when you can use typedict to help you at least have some sense in your kwargs. But yeah, I would say, like, if you can add the options in there, do. It's better. Explicit is always better than implicit. Zen of Python.
Still on kwargs, and it's Maxim Danilov that says that he thinks, sorry, but your example with Django create user does not work because on dev time kwargs contexts are not known. Or am I wrong and unpack work on work time or runtime, I think? In this case, you get exception on the next line.
Not to be honest, it might not work. I literally created those slides like 2 days ago, and I'm doing the presentation full YOLO. I'm sorry if some code doesn't work. Let me know. I can like provide how to make it work. But yeah, it can be that it doesn't work.
The code example doesn't work, but it would not be feasible to do the kwargs things on the create user by Django. Maxim? Okay, yeah.
We can discuss it simply later, and I show you why it's not working.
Okay, perfect. Again, I haven't paid full attention. You probably are correct.
Okay, now there's probably an inside joke because someone is asking you to tell us what is covariance.
It is.
Typing ninja.
Oh yeah, like a quick summary. Like if you have ever tried to use typevar, you probably encountered like the words covariance and contravariance. Not going to talk about this because it's actually very complicated stuff. But the basic is this: covariance is anything that when you have the type, like just like I showed, if you have a user, you can pass a user or anything that is is a subclass of it. If it is contravariant and you have a ninja, you can pass a ninja or a user because a person, because the person is a superclass of the ninja. Why would you, like, contravariant is, I think, it's the most complicated one. The use case is very niche, but again, not going to go into details because it's very complex. I could have a talk just to talk about generics in general.
Well, we have 3 minutes of time, so keep questions coming. There is another one who just popped up. What are your favorite arguments when discussing with typing skeptics developers?
So my main, I've had a lot of discussions with a lot of people that don't like typing. So one of my arguments is I was once a hater of typing as well. I was, as he said, like at the beginning. Back then, I have been a Python dev since 2010. Typing was not a thing back then. And when it got introduced, I was, like, if you want typing, go Java. Like, you should not do this in Python. It's not the Python way. But after a while, I started seeing some advantages, like, for example, if you want unit tests to cover most of your code. But let's be honest, like, you are never going to have 100% coverage. If you do, like, your project is probably outdated already. So having a good typing in your code makes it so that if you do a change in a code that is not covered by unit tests, at least the type checkers are going to alert you that, oh, you just changed the type of this variable, now this will not work anymore. Again, the unit test would catch that. That is usually what I get back as a response. But I think it's clever, like, to have it. And also, like, developer experience. You get code completions. You get documentation in your IDE. So yeah, why not?
Okay. There's Stefano, who expresses a feeling with many of us as fault. Fantastic talk. You showed an argument being typed as literal false. Why not just false?
Oh, this one, right? Let me find it. Oh, it's at the very beginning. Is it? Where is it? Have any of you seen it? Earlier? Okay. Oh, okay, it's here. So the thing is, like, so literal means like you are literally passing something that is inside literal. If I the typing itself, I can't, like, there is no false. There is bool. But if I pass bool, it catches everything. So I'm saying, if the overload and the order actually matters. So if someone calls get user and passes strict equals literally true, then this is the signature that I'm going to use. If it passes false, this could be bool as well. It would also work because I'm handling through here. So the only other possibility because of the ordering is false. But if I pass false, or if I don't pass anything and, okay, this is the default because equals false, then I get this signature. But you'll need literal because false itself is not type. False is an instance of the type bool.
Okay, we have just one time for a yes or no type of answer because we run out of time, and then you can keep asking questions later. And this is, would you make typing mandatory?
Yes.
Ooh, spicy. Let's discuss with Thiago and thank him again.
Thank you.
We might be running a little bit late because we are still trying to get a hold of the speaker, which happens. Gnocchi. Faccio vedere, se vuoi andare un attimo a provare a vedere la cicala, perché adesso appunto sono tornato qua, ho detto magari è tornata. L'ho vista Johansson, ha una maglietta nera, è abbastanza piccolina, sulla tendetta. Io stamattina l'ho vista un paio di volte. Sì, no, c'era, mi ha detto vengo 10 minuti prima, certo non c'è problema, abbiamo fatto il test. Adesso? Oddio. Who wants to talk about message queues? Not necessarily RabbitMQ. I mean, there are message queues everywhere. Peter, you want to talk about message queues? No, me. I know there is a message queue in Jupyter Notebook that is called ZeroMQ. We can just transform this into a lightning talk session. Huh? And in particular, you can start thinking, I mean, if you have a presentation ready, I mean, this might be the opportunity. Or okay. How did you go the conference so far? Good? Who's staying for the PyFest this evening? No, ci ho parlato proprio, nel senso, ci ho parlato più volte oggi, è venuta qua, ha fatto tutti i test, ha fatto tutto a posto. Dovete vedere una quiet room magari che si è messa lì a preparare la troppo? No, un posto possibile mi viene in mente. Eccola. We are, that's good. Okay, we are good to go. Thank you. We'll be ready in a minute. It happens. Okay.
Will you split out this?
So let's give a big round of applause to Lovisa Johansson for a love letter to message queuing. Thank you.
Hi, everyone. Sorry I'm late. I was chillaxing. I thought it was 12:55. It's great to be here at PyCon again. I was in Florence 2 years ago. It was amazing. And thank you all for taking the time to join me for this session. However, I might take you on a wild ride. The last time I gave a talk, I somehow managed to break the clicker, mess out the sound port on the computer, and my phone died right before on stage. So I had to borrow everything. So with that in mind, keep your expectations delightfully low and prepare for a few unplanned pauses. But isn't that what makes message queuing so great? It handles these pauses, like when a publisher is sending more messages than a consumer can handle. And it helps recover from issues when things go wrong. Depending on who you ask, the story about RabbitMQ might be told differently, but today it's my story. I will guide you through the history of RabbitMQ according to me. 2007 was the year of the first iPhone release. Back then, I played a lot of football. I liked dancing in the rain, dancing in the night. I also liked tapping on my computer. But I was also deeply into gaming. Counter-Strike was my gateway into tech, setting up gaming servers in the closet and hosting LAN parties in the basement was a true adventure. We spent hours running cables, troubleshooting connections, just to craft this ultimate gaming setup. 2007 also saw the launch of RabbitMQ, a message broker initially built to tackle communication problems, especially in the area of finance. That was 2007. A lot has changed since, including me today. I love the windy days. It gets me out on the water, kite surfing. I love the sunny days, just like it's here today. I could actually move here. It would be so nice. I like the first days of snow. It means I can take out the skis, go skiing, which I can't do here, I guess, but pretty close. What I don't like is the rain. But somehow I taught my kids that when it's raining, we celebrate and we go out and dance in the rain, and this is super cute. Until it happens at 6 a.m. in the morning, and they come running into the bedroom screaming, "Mom, it's time to get up. We need to go out and dance in the rain." And just like that, all the calm is gone. It's suddenly a lot of noise, activity, multiple kids trying to talk at once. They're pulling my sleeves, each with their urgent need. Digital systems, they experience this too when they are hit by too many requests at once. And that overwhelming, everyone talking at the same time, that's exactly what message brokers are designed to handle. Buffering the load, decoupling services, and keeping things flowing. With a queue, it's like forming an ordinary line. Each request gets handled one by one, and nothing gets dropped. Acting as a middleman between microservices is one of the most common use for message brokers. So we will look at 2 examples of that. Let's say you have just finished a run like I just did. You checked your app to see where you are in the leaderboard, if you set a new personal best on the course you ran. The IT architecture for this app is divided into different parts. Behind the scenes, a bunch of services, they work together. And these services include tracking the run, updating the leaderboard, and displaying the route on your app, on the map on the app. Building each service in the architecture is usually the easiest part, but somehow you need to, most of the time they do not exist in isolation. You need to coordinate and get these to communicate. And this is where threads of complexity starts to unreveal. And as far as communication, especially in microservices goes, 2 popular approaches graces the stage. We have asynchronous HTTPS and asynchronous lightweight messaging. And even though HTTPS communication might seem simple at first, it has some downsides. HTTPS communication tends to be tightly coupled due to its synchronous nature, requiring an immediate response at each request. But in reality, everything doesn't need an immediate answer. The leaderboard in the Workup app don't have to be updated this exact same millisecond as your race is saved. To handle millions of users, the communication between these services instead take place via a queue, and in this case, through a message broker and in RabbitMQ. When the gym closed due to the COVID-19 pandemic, more people started to run, more people started to use apps, and queues here helped to scale this app by lining up the task that needed to be done. So even if a lot of more people started to do workout at the exact same time, it just waited in line and was handled when possible. Another company that has built their infrastructure around microservices and queues is Parkster. It's a car parking app company. A sudden load, such as many users trying to pay at once, then these requests can be buffered up in queues, ensuring the system stay responsive. So we can look here. It's designed to remain operational even when part of the backend process is delayed or broken, like the payment service that we see here. So customer can have confidence when parking, as the system is designed to remain accessible even if this payment service is down. It also allowed them to use a different technology stack for each service. We have around 30 microservices in our architecture, mainly using Ruby, but also Python. That's why I've added Ruby here to this example. So this architecture means they can optimize services for the job, like making a performance critical one very fast without affecting the other services in the system. The different services can also be maintained by different teams if they want that, and also if they need to scale one part of the system. For example, the email service needs to scale, then they can scale that little service instead of scaling the whole application. This, of course, also saves some resources if you just have to scale a little part instead of the whole thing. There are, of course, many message brokers built in different ways. Some follow their own design, like Apache Kafka. They have their own their own protocol, while others are built around a common protocol, like AMQP, Advanced Message Queuing Protocol. It's a standard messaging protocol, kind of like HTTP is for the web and SMTP is for mail, but instead, it defines how services exchange messages in a reliable way with built-in support for flow control, acknowledgements, and delivery guarantees, and a lot of other stuff. Back in 2007, RabbitMQ was one of the first message brokers to implement the AMQ protocol. And RabbitMQ being open source from start was free for developers and companies to use. It attracted more users, especially as companies faced growing demands around data and user traffic. And if we take, for example, e-commerce around 2007, it started to grow a lot. And we started to have these events like Black Friday, which required that we had a platform that could scale with this growing industry. Just before coming here, I met up with some customers in Toronto, just last Monday, actually. They're using Celery with RabbitMQ to handle background tasks like message processing and API calls. And Celery is one of the most popular task queues in Python, and it's been around from, I don't know exactly, but I guess around 2009 when it came. And RabbitMQ was the default message broker from start. What I think was interesting in Toronto was that the customer I was visiting, they were not really knowing about RabbitMQ in the background. They just knew they pushed things to Celery, and they didn't really know how it worked in the background. So we did a really long workshop. It was super fun. Side story. What they did is that they defined tasks in Python, and when the application needs to run something in the background, like sending an email or processing a file, Celery sends that task to RabbitMQ. RabbitMQ is queuing up the work, and Celery workers process it asynchronously. We have a lot of Celery users. We have 15,000 servers today, and a lot of them are running Celery. After I finished my studies, I found myself on the beautiful island of Mauritius, and I spent a lot of time diving and working with system development. My colleague, or my university classmate, Carl, he was also busy diving in Bali, and this is where he started a service called CloudAMQP. And for over a decade now, we have been providing top-tier RabbitMQ servers in the cloud through CloudAMQP. And we have also seen significant growth, both in the industry and both in our company. We are today recognized as one of Europe's fastest growing companies. And this is pretty cool considering we are just a software as a service company for an open source software. I jumped on this project not long after 2014, and I must admit it was not really love at first sight between me and RabbitMQ. Initially, it felt complex. It was overwhelming with queues, challenges, protocols, connections, bindings, dead lettering, and every features that you can find. But over time and through hands-on experience, and I saw real customer cases, and I started to compare it with other brokers, I started to see its strength. And I found myself learning RabbitMQ at the same pace as I was teaching it and explaining it to others. And I have, during the years, been writing super many blogs, I don't even know how many, but also books around RabbitMQ. And one of the first features that really clicked for me was routing and how powerful the routing can be. It should be straightforward to direct messages where they need to go, whether it means broadcasting to many consumers or targeting a specific group or filtering by topic. And with RabbitMQ, you don't need to add a bunch of extra logic to make that happen. This is, how does this then actually work? We have the publisher who is responsible of making the message. In this message, it includes something called a routing key. Then it sends the message to the broker, and where the message ends up first is in the exchange, is the circle here in the picture. Then you bound queues to the exchange, and you bind them with a routing key, also called a binding key, on them. And then they match these routing keys on the message with the routing key on the binding. And the most flexible type of exchange is the topic exchange, and I will show that a little bit. And this might be a little bit complicated, but the meaning is to show that it's easy to work with when you know how to work with it. So I will give a concrete example. Imagine you're collecting metrics from different services running in multiple regions. So we have a schema like this, region.service.metrics. Each service then sends metrics like CPU, memory, disk, and so on to this. And here you can use routing keys, like you see here, EU-west.backend.cpu and EU-west.database.memory, and so on. This is just examples. And now you can bind different queues using wildcards. We have the star or asterisk that matches exactly one word. And then we have the hash, where you match 0 or more words. So if we have a queue bound with EU-west.hash, we will get everything from the European West region. So it will just look at the first word, and then it will take everything after that. Then we have another queue with hash.cpu. It will receive all CPU metrics, no matter region or service. So here it just looks at what's at the end of this routing key. Now here we can see that we get AUS.backend and US East.server, and all the CPU information will go there. A logging system could also subscribe to everything by adding a hash. So this could be useful for centralized monitoring, for example. We are using this when we are collecting server data from our customers, and then we send it to integrations like Datadog and so on. It's a simple idea that scales really, really well. RabbitMQ comes with a user-friendly interface, and you can add queues, set up exchanges, send messages, all from the web browser. And back around the time of 2015, the RabbitMQ release 3.6 came, and it gave us some serious troubles. There was a memory leak in the statistic database. It was fixed pretty fast, but it was still really long nights. We were just 3 people in the team. So we had to be up all night troubleshooting these out-of-memory errors. Back then, RabbitMQ also handled message differently than they do today. Before version 3.6, messages were mostly kept in RAM, and only flushed to disk when the memory was running low. And that approach worked really well until it didn't. So under high load, it meant RabbitMQ sometimes had to dump a large volume of data to a disk all at once, which then caused performance issues for us, and we had to deal with that. But 3.6 introduced something called lazy queues. Instead of holding all messages in memory, lazy queues then wrote them directly to disk instead. And this reduced the memory usage and made RabbitMQ much more stable. So instead of going like this when there was a peak of messages, it went flat. We quickly adopted lazy queues as the default for our multi-tenant servers at Cloud QP. We have free users that are sharing the same RabbitMQ server. So here we put lazy queues directly. The same year, 2015, we also started hosting other services. We were still 3 people. We were hosting RabbitMQ, Apache Kafka, Postgres, and Mosquito MQTT. And it was around this time, I think, I started to feel more for RabbitMQ more and more, because I didn't really like Kafka. RabbitMQ's flexibility, ease of use, and ability to handle enough data for most use cases won me over. Fast forward to 2019 and RabbitMQ 3.8. It's my favorite release. 3.8 introduced quorum queues. And these replicated queues ensure data safety through a leader and follower replica architecture, where the followers provide redundancy. If we quickly compare them to classic queues, we have the core difference in that classic queues, they are fast and they are feature-rich, and they are on a single node, lacking high availability since version 4.0 version that we have right now. They offer things like time to live, queue length, limits, and priority of messages. Quorum queues, on the other hand, ensure data safety and HI through replication across a multi-node cluster setup. Typically, you have 3 or 5 nodes using Raft for leader election. Streams were introduced during 2021, making RabbitMQ an attractive option for users seeking Kafka-like features in a RabbitMQ environment instead. Of course, we also need to compare them compare streaming to classic queues. In a classic model, a message goes in. One consumer picks this message up and processes it, and then it's gone. Messages are usually handled in the order they arrive, first in, first out, and the goal is to distribute work efficiently across services. RabbitMQ handles streaming as a persistent append-only log, meaning messages stay in the queue even after they have been read. Here, multiple consumers can read the same message, each at their own pace. Each consumer tracks their position in the stream using something called an offset, and if needed, they can reset this offset to reprocess past messages again. And how do then this work? How does it look in practice? Here we have a customer running a website tracking system. Every click, every view, everything falls into a stream. The marketing team watches this stream to see which campaigns that drives engagement. At the same time, the product team, they look at the same event to spot usability issues. And the recommendation engine, they tap onto the same stream to suggest content in real time. Now, for example, if the recommendation engine falls behind for some reason, if there's a spike in traffic or something like that, the other team, they are not affected. They can process the same stream at their own pace. And later, the product team can rewind and replay yesterday's traffic to test a new feature without distributing the live feed. And this is where streaming really shines. Use cases like audit logs, live dashboards, system recovery, and personalized experiences. In 2023, RabbitMQ added support for MQTT, which led us to phase out our own MQTT service. It was called Cloud MQTT. It doesn't exist anymore. The same happened when, with our Kafka hosting, RabbitMQ streams matured enough that we could focus on one solid solution instead of having 4 different products running. Since I started, I have worked mainly with version 3, but this last year, RabbitMQ was released in version 4.0, and I hope it will treat us well. For us, version 4 means deprecation of something called classic mirrored queues. And we are really looking forward to more people moving away from this classic mirrored queues, since it has been, we want to see less performance slowdowns and data sync problems. A common use case for message queuing systems is managing a high volume of email deliveries, particularly businesses that are sending thousands of emails or even operating an email automation service. Message queues plays a critical role in helping this system scale by decoupling the generation of the emails and the request of the actually processing of sending this email. So they send the request to the message broker, and then the one sending the email receives the message and sends the message. Another use case for message queuing is in the workflow solution for manufacturing. This is a company called Rever. Here it allows users to report observations, safety hazards, and improvement ideas from the factory floor via a phone or an iPad or something like that. And at the heart of their infrastructure, they have RabbitMQ ensuring seamless communication between all the services they have. So each user-generated request or report is encapsulated as a message and published to RabbitMQ, which then routes this message to the appropriate backend service for processing, analysis, and storage. And these messages might later trigger workflows such as automated alerts to supervisors or updates to safety dashboards. And they are today sending hundreds and thousands of messages per day. Many modern applications require real-time communication between backend systems and users. And WebSockets makes this possible by enabling persistent two-way communication between a client, often a browser, and a server. And this opens up for a range of practical use cases. For example, live monitoring dashboards that reflect backend changes instantly. And in these systems, RabbitMQ acts as a reliable and scalable message broker, while the WebSocket serves as the delivery channel to the end users. And one example of this in production is Visman. It's a leader in heating and cooling technology. So the system pushes status updates to RabbitMQ. The backend service consumes the message and forwards them to via WebSockets, providing a real-time feedback from the physical devices directly to the user interface. At CloudMQP, we have seen RabbitMQ manage real-time updates and keep everything organized in many taxi and logistic firms, where they, among other things, constantly are sharing GPS data through RabbitMQ. We have seen RabbitMQ in some of the world's most recognized companies. We have customers. No, no.
Let's try disconnect and reconnect. There is a message queue in between this and the screen, probably. We are publishing the connect message.
No, maybe.
Let's try from here, maybe.
Now.
Yeah. Oh, no, okay, yes, we have.
Is it? No. Okay, then we start over. Fast forward. This is just attentional. Refresh. So, we have seen customers, including several of the world's most famous car brands, one of the world's largest breweries, a newspaper in the US that reaches 65 million readers a month, where queues handle everything from breaking news alerts to lining up articles and that will go live and so on. And a large company for payment solutions. And we have seen it in health journal systems, in governments, and I could keep on mentioning almost every part of society. But I will not do that. Instead, I will show RabbitMQ is also used in a wide range of use cases across all these industries, from work queues in microservices to IoT, where it connects devices and systems, whether in warehouse or smart homes. It also bridges legacy systems and modern architecture, like when you have an old stack that you want to move to something new, a message queue is also sometimes often used. And with streams, as you saw with the example of the web shop. I just wanted to show this picture also. We have, as I said, 15,000 servers. This is the spread of the programming language used. Python is the second most programming language with the client library Pika. So I will wrap up this session. AMQP, it's been a long time. It's been here a long time. It's trusted by me and many others. RabbitMQ supports a wide range of use cases, from IoT till real-time streaming or acting as a middleman in between microservices. It scales really well. In fact, we have never seen a customers outgrow a single RabbitMQ server. And it's easy to use with built-in HTTP-based management interface. So RabbitMQ has shaped my journey and many others. It's powerful, practical, and dependable. And I'm especially grateful for the community. Thank you so much for listening.
Thank you, Lisa. Thank you. We ran a bit of overtime, but there is the lunch session, so I don't think we are really pressed for closing. So if you want and go and have lunch, you can go. But so please feel free, because we are really over time. So feel free to go and. But we have a few questions, so maybe I'll ask a few questions that you might be interested in the answers. So one is there a guarantee that the first message put in the RabbitMQ queue will be processed first?
Yes. It depends. It depends, as always. If there is one consumer, the message will be processed first. If there is a lot of consumers, the message will be first in line, but then it depends how long time the consumer will take to process this message.
Okay.
So it will go first out, but it's not sure that the consumer that processes it is faster than the second message. I complicate this stuff, but.
How do you monitor spikes in RabbitMQ messages in production? Since RabbitMQ hosts sample statistical data in every 30 to 60 seconds, we miss a small outage which happens less than 30 seconds ago. Any tips?
Sorry, can you?
This is
It
the
was a
question.
long question.
Yeah.
Is this from the management interface? Or
We can skip to the next one, and maybe the person that asked the
Yeah.
question can reach out
Yeah.
to the speaker and explain better. Can you compare the latency of a lazy queue with regular queues? I guess that this CRED will be slower than memory read, but how
yeah,
much?
the lazy queues are slower, but now it's built into the classic queues. They are all using lazy queues, but not lazy queues. It's rebuilt. So it's actually pretty fast in the new classic queues.
Is RabbitMQ always preferred over something lighter like Mosquito?
We like RabbitMQ much because we have the acknowledgement, we have publish confirm, we have acknowledgement of messages. It also feels more stable than our MQTT Mosquito service that we were running.
Okay. And you mentioned Kafka. Was it straightforward to replace it with RabbitMQ? Is there anything that Kafka can do and other MQ systems not?
There are, of course, things that Kafka can do that RabbitMQ can't do. Log compression, for example, doesn't exist in RabbitMQ.
Okay, so thank you again, Lovisa, and thank you all for staying. And it's lunchtime, so see you at the pool.
magari, guarda, vado solo a chiuderti le porte. Oh, okay, so we can start. Hello, everybody, and welcome to this first session after the lunch break. We are here with Luca Corbucci. Luca is a PhD candidate at the University of Pisa, and today we will explore the world of federated learning. And please, if you have questions, put them in Slido. So, Luca, the stage is yours.
Thank you for the... Thank you for the introduction, and thank you all for being here. I hope you had a good lunch break. So, I want to start this talk with a question that may feel strange, because as you know, I've heard the talk is about federated learning. But I want to start asking you, how many of you use Google Gboard on their smartphone, on Android? Probably you're using it, but okay. Okay, and do you know how the models that are behind this keyboard are trained? Okay, okay. We will see something about this today in this talk. The title of this talk is Learning Together Distributed, and I will introduce a little bit the idea of federated learning and how we can implement it and how this is used in some real-life use cases, such as the one that I just mentioned. I'm Luca, and I'm a PhD student at the University of Pisa, close to the end of the PhD. In my free time, I'm a podcaster. I have a podcast called Pointer Podcast, and I also help a couple of communities, one in Pisa. So before introducing federated learning, just a quick recap of how the classic machine learning works and to understand better what are the differences then with federated learning and why maybe we need federated learning. So when we want to train machine learning models, the first thing that we need to do is to have some data to train the model. So the first step is that we have to collect some training data. In this case, we have some cats photos, and so we have these images. We want to train a model, so we have maybe to put this data on a server, and in the end we have our model that will predict the color of the cat in the image. Usually, this is done, as I said, using an external server, relying on a server that is responsible both of aggregating all the data. So you have to trust this server, send to this server your data, in this case, again, images of cats. And then what happens is that the server will also will train the model at the end. So he will be responsible to train the model with the data that you send to it. So this approach has, obviously, it has some things that are really good, but there could also be some problems. So it is easier to train and also to debug because you have all the data in a single place. You don't need to take care of the fact that users have different kind of data, that this data is distributed among different locations, different devices. Around the training of these centralized models, there is a more mature ecosystem. There are more frameworks, more like debug tools probably also. And in general, you can find more resources online if you have any problems. The other important thing, since you have all the dataset aggregated in a single place, you have a view on the entire dataset. This can be particularly useful because you can understand at the very beginning of the training how your data is distributed, and maybe you can handle the problem that you could have in the dataset, maybe with some groups that are less represented than others. There are some problems at the same time because you have to trust the server. You have to trust that the server that receive your data will just use your data to train the model. And there are also some limitations because of some regulations. Like, for instance, in Europe, we have the GDPR. There are also similar laws that can somehow limit the data sharing, that can limited data sharing between different countries, but also put some regulation on how the different companies has to handle the data. And there are also some scalability limits because you have to put all the data in a single place. So this company, as long as you have more data, you have to have more space to store the data, and maybe the models that you have to train on this data are bigger and bigger the more you have data. So what was introduced a few years ago to solve some of these problems was federated learning. This idea was introduced around 2016, 2017. The first time I heard about this was, I remember I was watching Google I/O, and since this concept was introduced by Google, they were talking about this federated learning at that time. I couldn't understand some of the things that they were saying, and then after some years, I started working on this topic. So the main idea is that instead of moving the data, that is what we have seen in the previous slide, we move the models that are trained by some clients, and I will call these clients nodes or users. I will use different terms, but basically these clients are the people that want to train a model, or they could be entities like, I don't know, hospitals or different companies. And then after you aggregate this data, after you move these models on a server, what happens is that you have to aggregate these models. As you have seen in the previous slide, the paper in which federated learning was introduced was published in 2017, if I'm not wrong, or 2016. But now, in the past 2 or 3 years, I've started to see more interest about federated learning. And I think that this is mostly because of 2 or 3 reasons. The first one is that probably we have more interest in some privacy problems that could arise when we share data with external servers. There is also more compute at the edge. Today, a simple smartphone can probably train a small model and share it with some external server. And there are also better tools to implement federated learning. When I started working on it around 3.5 years ago, I started working on some framework because I couldn't find a really good framework to use. And today we have a different solution that we can adopt instead of like reinventing the wheel every time we need to use federated learning. So just to see an example of what happens when we use federated learning instead of using a classic machine learning training. So in this case, we have, again, 6 different clients. All of these clients have some images, some photos of their own cat. And what happens here is that if they train their model only on their images, each of these users will only have some images of their own cat. So what happens is that the model will all be able to recognize a single cat. So what they could do is to move their data to a server, or the alternative solution could be to use federated learning. So in this case, you still have an external server, but what you move to the external server is not the data, but the models that you train. So basically what happens is that you take your data, you do some local training, and this is orchestrated by the server. So the server tells you, you have to train your model, you start the training, and then you move back the model to the server. This is executed one first time. Then the server takes these 6 models, in this case, and it has to aggregate these models in a single one. Usually, this process is done with a strategy that is just the weighted average of the weights of the model, and this algorithm is called federated average. And this is more or less the baseline algorithm for federated learning. There are some other strategies that you can adopt if you need to to use federated learning. There are some strategies that, for instance, take into account the fact that some clients could be slower than others, but these are tailored for some specific scenarios. In general, you just do the average of the weights. And then what happens is that the server starts another round starting from this model. So the different clients, in this case, we have 6 clients. So the 6 clients will receive these aggregated models, and they will start another round training this model on their own data. This can be done for different rounds until you reach a certain accuracy of the model, or you could even continue until you want to train it. In this case, we had just a few clients, 6, but this can be extended to 1,000 or million of clients. I will show you now an example of, we can go back to the question I asked to you at the beginning. So the models that are behind the Gboard keyboard that is on the Android phones are trained with federated learning. And this was one of the first use cases of federated learning. This is another paper published by Google just after a few months, I think after the first one. And they explain how they were training the model to help users to have some suggestion about what to type using federated learning. So in this case, the different clients are the smartphone of the people using Android and using Gboard, and they were training, in this case, I think a recurrent neural network to predict the next token. During time, this thing evolved. So they started with simpler model, and then during the years they moved to something more difficult to train. In this paper, for instance, they were training a language model to help users, again, to have right predictions in Gboard. And they were not using federated learning, but they were also using some technique to improve and to guarantee more privacy to the users. Because I said at the beginning of the talk, I said that you have more privacy because you don't share the data. But even if you don't share the data, the model that you train is still could potentially still be vulnerable to some attacks. And for instance, in this case, they use differential privacy to avoid these attacks. This was also discussed in another blog post on the Google blog, and they were again they explain how they use the federated learning to analyze some data coming from the different users. And if you go to the web page about the Gboard, they explain to you what happens on your phone when you take part in this federation, and they also allow you to opt out and avoid that they train this model with your data. Another use case, again, it's another use case using a smartphone as a client. I don't know, many of you use Siri, but anyway, this one is another paper published by Apple. In this case, they use federated learning to train some speech recognition models using data that are on user device. So users don't share this data with Apple servers. They just train the model on device, and then they share just the model using federated learning. And even in this case, you can see they use differential privacy to preserve the privacy and to guarantee some privacy to the users. And if you want to know more about differential privacy, there are a lot of blog posts online, and I also did a talk last year at PyCon. I was mentioning the framework at the beginning of the talk. There are a lot of different solutions now to implement federated learning. Most of them, I would say, are more for research. There are, for instance, FLSim, that is a framework by Meta to simulate the federated learning. TensorFlow Federated is another solution by the TensorFlow team. These other, FedML, OpenFL, Federated Scope, are less known. There are also a lot of implementations. If you go on GitHub, you can find a lot of implementation of federated learning. Most of them, again, are just for research. If you need to propose something different, maybe you need to write your own framework, or at least to simulate something, writing a custom framework. The one that I use more or less every day is this one that is called Flower. I started to use it around a couple of years ago, and I did some research when I started to use it, and at that point, it was the best one among the other options. Now, I think that this is the... So I would really suggest you to start with this one if you have to start using federated learning. I like this project because it's an open source project. They have everything on GitHub, a lot of tutorials, a lot of examples that can be useful to start learning it. There is a nice documentation with, again, a lot of tutorials. And there is also a nice community around the project. Not only they have a Slack channel in which you can ask help about Flower and federated learning in general, but they also organize a lot of events around this framework. They organize a conference, and if you go to their website, you can find all these talk that they gave at this conference. They invite people every month to present what they do with federated learning, and they also have some useful resources on YouTube to learn how to use Flower. It is a framework that is written in Python, and if you have to develop some components for Flower, you have to write them in Python. And in terms of the backend that you can use for the deep learning, there are different solutions that can be adopted. It is more or less agnostic with respect to the framework that you can use. You can use PyTorch, TensorFlow, JAX, and there are also other on their website with a lot of tutorials. You may, at this point, ask yourself, what about Android and iOS? They are working on it. There was an SDK that was developed for, it was an SDK that was taught to develop federated learning applications for Android and iOS. At the moment, it's not supported. And on their website, they say that this will be available in 2025. I was also checking for some JavaScript SDK because I wanted to do a more interactive demo for this talk, but they don't have it yet, at least the last time I checked. So Flower is also nice because they allow you to both simulate the training of federated learning models, but also to do the deployment. In my case, this was, so I always use Flower for simulations. For the simulation part, what it is nice is that you don't have to take care of how the simulation works. You just have to set some parameters, like, for instance, the number of nodes that you want to have, the number of clients that you want to have in the federation, so the number of clients that will actually train the model. You have to select what kind of data set you want to use, how this data set is split into the clients, and everything works without too many problems. On the other side, if you want to deploy it, I've seen that they have different tutorials on their website. They have a tutorial to deploy Flower on Google Cloud Platform, one for Azure, and they also allow you to create different Docker containers with the clients and the server to distribute your federated learning application. And we will see an example with Docker later. So the architecture of, in general, a classic federated learning application is composed by two main components. One is the server, and then we have the client. This is in general for all the framework. It's not specific for Flower. In the case of Flower, they hide some implementation around behind two main components that are the super link and the super node. So the server basically is split into two parts. One that is the super link that will take care of the communication with the different clients, and one is the server app. You will probably only touch the server app. So in the server app, basically you will have to write some logic of how the server works. For For instance, you have to specify your strategy, how you want to aggregate the weights. In general, this is something that you don't change unless you have some specific requirement. On the client side, instead, you have the super node that is, again, the one that is responsible for the communication. And then you have the client app that is the place in which you define your client that requires basically one method to train the model and one method to test it. So the nice thing about Flower is that it hides the complexity behind the complexity of the communication. So you will not need to deal with the communication between the clients and the server. So I wanted to show you a demo of how Flower can be used. So I wanted to show you an example of how to create a simple Flower app. I will use the Flower command line interface. That is something that was released recently. For simple application, I think it's a nice way to start using Flower. Maybe if you need something more difficult, probably in the end you will end up in writing your components and without using the command line interface. But for this example, I think it's really nice. So in this case, I start creating a Flower app. So with the Flower run command, you can okay. Okay, yeah, because it's Flower new. Okay, I have to type the app name, my username, and then you can choose the machine learning framework that you want to use. In this case, we will use PyTorch. Okay, so can you see it? So now we have this new folder with the Flower app that contains some files and some other another folder in which we have our clients and server. Now let me just delete it, and I will copy there the one that I prepared for the demo. That is already ready for the talk. So, okay. I wanted to show you what's inside this one. So, in the PyProject file, you can find all the settings about the simulation that you want to run. Here, for instance, you have you define some setting about the number of training rounds that you will execute. So the number of time the server will select the different clients and will ask the client to train the model. This number here is the percentage of clients that are selected in the different training round. So in this case, we are selecting 0.05%. The 5%, sorry. And then we have the number of local epochs that the client performed during the training. And here, this number is the number of the clients that will perform the training. With the command that I used before, so Flower run, you can start a simulation. Yeah, I have to move to the folder. You can start a simulation. And now we will start it. Okay, so in this case, for instance, we selected 2 of the clients, and we had 20 clients in total. Now it is running the training. In the meantime, I wanted to show the other parts of the app. So in the task file here, can you read it? So we defined some methods and some classes that can be useful during the training. We have the definition of the neural network that we are using. We define the data set that we are using. In this case, we are using MNIST. So the task is to classify basically digits. And we also define how we want to partition the data. Since this is a simulation and we are using a data set that is not taught for federated learning, we are just splitting this data into 20 parts. In this case, in an ID manner. So this file just contains some additional function that can be used, for instance, to train the model, test the model, nothing else. These two functions are used by the clients when you receive the model from the server. When you receive the weights of the model from the server, you then have to put these weights into your model, and so you have to define these two other functions. We have two additional files here. One is the server, and here you can find the definition of the strategy that you want to use in the server. In this case, is fed average, and you pass here some of the parameters that we defined before, like the fraction fit, for instance, the percentage of clients that will be used during the training. And in this case, this is instead the number of clients that will perform the test. And this is the server. Last thing I want to show you is the client. It's nothing too difficult here. In this case, you just have to declare two functions. One is to train the model, one is to evaluate it, and then you have just to declare your client. And we can go back to our training here. In this case, so I don't have the accuracy here, but we can see that the loss is decreasing during the different rounds. And this one is, again, an aggregation of the losses of the different clients. So it's like an average of the losses of the clients. And we can see that we are somehow learning something. The nice part is that with using this command line interface and using this configuration file, I can put here any number of super nodes. I can start again the simulation, and then in this case, the dataset will be split into 500 clients instead of 20. And I have to say that they did a great job in under the hood to manage all these the training in parallel in the different clients. So even on a laptop, you can still run the simulation even if you are running 25 clients in parallel. So I can stop it, and I wanted to show you one last thing in the demo. I said to you that you can also create some. You can also run the clients and the server in some Docker files, some Docker containers. So in this case, in the original PyProject file, we were asking Flower to run the simulation on our device. But what you can do is also to add some. Oh, just 1 second, sorry. You can also specify some additional parameters about how the server is located, basically. In this case, we are saying that we have this server listening on this on this port, and I've created a simple script to run the different Docker containers. This is something that I usually don't do because I mostly do simulations, but I prepared this because I wanted to show that it's also possible to run this Flower in multiple machines and in multiple Docker containers. What we need for this simulation, for this test with the Docker containers, is a super link that, if you remember, is the one that is responsible for the communication. We need a super node, one super node for each of the nodes that we want to create. So we have one server, and then we have 5 super nodes. So we will have then 5 clients that are these ones here. And if I run these, hopefully it will work. Let me see if. Okay, let's see if it works. Okay, so the containers are running now. And what we can do is to ask Flower to run these new simulations that is run with these clients in the container and with the server in the container with a different flag when we run it. So instead of using Flower run, we have to say we have to add deployment here. That is the name of this additional setting. And stream is just an additional parameter that we can use to see more details about the execution. So in this case, the server is in this Docker container, and we have 5 Docker containers also for the clients. So you can see that in this case we have 5 clients, and we are selecting 2 of them, while here we have 500. So we are using this second branch for the execution, basically. Okay, so I can go back to the slides for some final considerations. So just to summarize what I've said. So there are mainly the main difference between centralized learning and federated learning is in where the data is located, basically. In the case of centralized learning, all the data is in a single central server, in a single location. Federated learning is more respectful for the privacy of the user, because they don't need to share their data. So in this case, the raw data never leaves the different devices. This can be useful specifically for some regulations, and from what I've seen, this like federated learning is used mostly in some scenarios where people are really interested in not sharing the data, like for instance in healthcare applications. I've seen that different startups are using federated learning for this in this scenario. I would say that in terms of learning materials, tutorial, and in general also framework, if you want to start training some like classic machine learning, centralized learning models, you can find a lot of tutorials, a lot of framework. With federated learning, nowadays there are more and more tutorials, and it's easier to start working on it than it was 3 or 4 years ago. Some other considerations that are worth to discuss. The first 2 are important if you run federated learning application in real life scenarios, because you have to deal also with clients that decide to stop doing the training. You have to deal with some latency that is maybe because of the network. It could be because of maybe some clients have a smartphone that is cheaper than others, so maybe they have like they stop the round. You have to wait for some clients, basically, because some of them are faster than others. These are in real life scenario, and as I was saying before, there are solutions that try to solve also this problem, like asynchronous federated learning. The last thing is a problem that you have both when you have to simulate the federated learning training, but also in real life scenarios. You have to deal with the fact that users are different. So people maybe that are located in some parts of the world could have different data that people that are located in a completely different part. So you have to deal with underrepresented groups of clients. You have to deal with models that maybe start to treat user differently. So this is a problem that is still present in federated learning, but also in the classic machine learning. And I've worked on a little bit on this part of fairness and the training of federated models. If you want to learn more about federated learning, I would recommend starting with Flower. I don't work with them. I just really like the framework and this project. They have a lot of tutorials on their website, and they also have a nice playlist on their YouTube channel in which they presented all the things that I discussed today in like with more and more videos, and in like trying to understand better what are the different parts of the framework. Some things to conclude. I've seen that during these last years, there is more interest in data privacy, and so also in federated learning, especially in some sector, as I said, in the healthcare one. I think that this can be one solution to deal with this problem. If you are thinking about this, even bigger models can be trained with using federated learning, even a large language model. There are some examples of these, again, on the Flower website. They not only they train as a large language model with 1.3 billion parameters, but they also presented like some tutorials to fine-tune large language model using flowers, and they have, I think, some resources also about how to do this. One last bold statement that was written on the bags that Flower team gave us when we went to the conference. They think that the future of AI is federated, and I mostly agree with them, because all the data that we create and all the scalability problem that we could have with all this growing amount of data could probably be solved using a distributed and decentralized learning. So this is the end of my talk. Thank you and if you have any question, I'm happy to answer.
Thank you, Luca. So there are some questions here in Slido. The first one is the advantage of going federated related to energy, lower overall cost, time, it takes less time to unite many models, or something else?
So in terms of time, and also in terms of how difficult it is to train the model, I would say that if you run the centralized learning, you can be faster in the training, and you can probably obtain a little bit better results. There are studies and papers that studied like what are the differences of training models with federated learning and centralized learning. In the original one, they compared the training of two models, showing that there was a small difference in terms of accuracy. In terms of energy, from the point of view of the company that has to train the model, they are probably happier to use federated learning, because they don't have to train the model on their own server. You will have to train it. On the other side, they will not have your data, so there is a trade-off. And I don't know if there are other parts of the question.
No, they just ask if there is something else that is an advantage.
From the user point of view, the main advantage is that you don't share the data, and from the
privacy.
Yeah, the privacy. Yeah.
Okay, so the second question is, what happens if someone sends a worse model, for example, a model trained on images of dogs? Can you intercept this?
So there are studies on this, and it's called model poisoning. And in this case, so it depends a lot on the scenario, because even if you send a malicious update, if you are in a scenario in which you have like millions of clients, maybe you are selected today for the training, you send your malicious update, and then you are not selected for the next 6 months. So your update will be basically useless in the end, and you will probably be less important than the others. This can be at the same time a problem, because if you are not malicious but you just have a different data distribution, this could be a problem. So there are some studies that study some papers that study how to deal with these model poisoning solutions, but as far as I know, there are no real solutions that solve this problem. Because if you, for instance, if you receive some models update and you say, okay, this one has a different weights distribution than the others, it could be because it's malicious, but it could also be because it has a different distribution. If you decide to not to use that model in the aggregation, you could avoid aggregating one model that is malicious, but you could also aggregate a model that comes from a user that is just a different user than the other. So you could have, for instance, fairness problem at that point.
Okay, thank you. So I lost a question. Uh, okay, probably there was a question, but I lost it, so I will read this one, and then if there is someone with a question, I can. Ah, okay, so you deleted. Ah, okay, thank you. So the last question is, in your opinion, do you think that federated learning is better for data privacy rather than using synthetic data to anonymize raw data?
This is a nice question. I'm not too expert on the synthetic data part. I know that there are some different opinions on this, on how, if the creation of synthetic data is guarantee some privacy to the users or not. So I don't know exactly what to say here. There are I know that there are some papers that also studied how the synthetic data, if synthetic data are really privacy preserving or not, but I don't know too much to answer this one, sorry.
Okay, so the very last one. Can you flag users in non-ID federated training by demographic, like separating Italian and English Gboard user for training? Speaking of which, is there research on a mixed approach using both federated and centralized data?
So for the first part of the question, in theory, if you know this information about the user, you can already infer some information that you shouldn't know about the user because you know the distribution of their data, and in theory you shouldn't know the distribution. There are some way maybe to share some information about the distribution of the data of the clients using, for instance, differential privacy to preserve their privacy. So in theory you shouldn't know the distribution of the data. And the second part, again, sorry.
The second part is there research on a mixed approach using both?
So the thing that I've seen is that in some cases, some data is used on the server side to maybe pre-train the model, but in this case, you assume that you have some like external data that is not coming from the user, but is maybe data that you can find online. But in general, the constraint you have with federated learning is that you don't share the raw data of the clients, and you shouldn't also share information that could reveal something about the clients that you didn't know before starting the training, basically.
Okay, thank you, Luca.
Thanks, thank you.
bit, yeah. Right.
Okay, I think that we can start. So welcome to this last session before the afternoon coffee break. So we are here with Sebastian, who will provide us a guide to security. Please, if you have questions, use Slido. And Sebastian, the stage is yours.
Yes, thank you very much. Well, hello. I was going to start with a joke about the name of the room because it sounds delicious, but I don't know how to pronounce it. I think it's gnocchi or something like that. And also, I don't really want to talk about food anymore because the lunch was so awesome. I just ate a bit too much. So it's already been a very long conference. I hope you had a lot of great talks so far, and this is actually, I think, the last round before the keynote. So I'd like to start with a little bit of a story, just to have an easy start with the talk. And I would like to talk, well, not about Python, but something that sounds like it. I would like to talk about pirates. So this is maybe a quintessential pirate, as you know it. It's a drawing, but it's actually based on a real-life person. And his name was Cornelis Jol. He was a Dutch guy. And while researching this talk, I actually found out that we are related. So we actually have family connections together, which is not that surprising because he's from a very small town in the Netherlands and my mother's family is from that same fishing village, and I don't really want to think about all the family connections that we may share historically in such a close community. But anyway, he was a real pirate. He looks the part, right? His nickname was Houtebeen, or Wooden Leg, or Leg Pack, and he is actually one of the first documented pirates that had a wooden leg. So that was actually a thing that existed back then. So if you have a sword fight and you get a nasty cut, well, sometimes it's better to take the leg off, and then you still have to walk. But anyway, he really looks like a pirate. But there's actually some debate about whether or not this is an actual pirate. He looks the part. And for us Pythonistas, it's an easy question to answer because we have duck typing. If it walks like a duck, if it talks like a duck, well, then it's a duck. Well, this guy, he definitely walked like a pirate, he talked like a pirate, he plundered like a pirate, he robbed like a pirate, he killed like a pirate. So, using our duck typing logic, this is definitely a pirate duck. But in reality, if you want to be historically accurate, things are not actually that clear. And the actual answer, well, it's quite interesting, it's quite of a novelty, but the discussion about whether or not this guy is a pirate actually has a lot of insights in the world today. Because today we have a very similar situation on our hands. So that's why I would like to talk a little bit about whether or not we should call this guy a pirate, and then translate it back to our threats that we have in our current geopolitical situation. So to understand this guy, we have to travel back to the age of discovery, or the age of exploration. So this is a photo of a replica of the ship that Christopher Columbus used to sail west across the Atlantic in the hopes of finding the Indies. Well, he actually found the Americas, But as you can see, it must be quite terrifying to step on a ship like that and embark on a journey across the seas, not knowing where you might end up. But as much as I love exploration, in reality, a lot of, in this day and age, was just about money. Because what we wanted to do is we wanted to trade. We wanted to get the spice trade. Actually, in the Netherlands, we call the last period of this age of discovery, we call it our golden age. It's when you get famous paintings like this one. This is the Night Watch by Rembrandt. Now, if you want to hurt your throat, you should try the Dutch pronunciation. It's Nachtwacht. So try that sometimes. And by the way, we still call this the golden age because we earned a lot of money. But for me personally, we were not just trading spices, but we were also trading our fellow human beings. So whether or not we should continue to call it the golden age, I don't know. But anyway, I digress. What we really have to talk about is that with money and with trade and with the economic situation, there was a geopolitical situation. With many, many, many great players in the world, Spain, Italy, France, England, the Netherlands, and what have you, they were all basically just fighting it out for the spice trade and other types of trade all around the world. They all wanted to control that situation. Now, back in the day, the best way to travel long distances was by ship. So what did we have to do? We have to fight. That's why we have a lot of famous sea battles happening at the time. And we were literally, because we've just invented or stole the invention of gunpowder, blowing up each other's ships. But building a navy is very expensive. And in fact, a lot of the naval engagements we get in that time weren't done with actual naval ships owned by the state. And the reason for that is actually really simple. Building ships and boats is really expensive. This is a period of great change, a lot of regime changes over time. There wasn't a lot of money belonging to the state, to the republics or the kingdoms. So we had to turn to something else. Luckily, we were a very enterprising folk. We had a lot of entrepreneurs. So here you see an image of the first, what they call the first modern stock exchange. This is the stock exchange of Amsterdam. It opened at the start of the 17th century in 1608. So we were really, really doing business by then. And actually, we call this the first modern stock exchange, but if you go fairly close here to Venice, we already had money lenders that were trading debts and credits and stuff all over the place. So that's even a little bit debatable as well. But anyway, so what do? You are a state, you don't have money, but you do want to wage war. Well, you do the same thing as we do now, you privatize. And that is what happened back then as well. So rather than just having a navy, we would basically legitimize pirates. We would give them a letter of marque and reprisal is what we call it, or a kapersbrief in Dutch, because we Dutch were really good at it as well. And basically what it meant is you are just allowed to do your pirate thing. You can plunder other ships, you can plunder coastal villages, you can be an actual pirate under one condition, and that is that you do it to the other guy. So we have all these geopolitical tensions, and we legitimize pirates, we give them a pretty letter, and we tell them, now you can do it to the other guy. And one very famous pirate, or we should actually call him a privateer or a corsair, was Sir Francis Drake. He hailed from England, and here he is with his loot from a Spanish ship. This is really a testament to how well respected these guys were. Sir Francis Drake was an important guy in England at the time. He's actually the second person to circumnavigate the globe. Not the first, but the second is still very impressive for the time. So he was a well-respected pirate. And the reason he could do that is because he had the permission of England. And that meant that he had a safe haven. Because as you probably know from your favorite Disney movie, the typical punishment for piracy is death. We really didn't look kindly towards pirates. So it was really a good thing to have safe havens where you could go into port, unload your stuff. You did have to pay taxes. There has to be something in it for the king or the republic, obviously. But now you had a safe haven where you can just offload your goods. There were legal procedures for the ships you captured, so they became your property and you could sell them off. And you can recruit sailors, because now suddenly, rather than being this outlaw living in the periphery of society, you can offer people an actual job. So this was really an important aspect of these privateers. They had safe havens. Now obviously, if you're on the other side, if you're the enemy, you'd just call them pirates. And they were really a menace, so there were often conditions of just putting them to death anyway. Now, you might think that these pirates were just plundering ships, but they actually also did naval engagements. So Sir Francis Drake, the guy that we just saw, he led, as an admiral, he led several attacks against the Spanish, and in one of them, he took 25 ships, and 23 of them were not naval ships. They were actually private ships, just being paid to pillage and raid Spain. And there was a very famous privateer group in modern-day France, but it was the Spanish lowlands back then, here in Dunkirk, who were very famous. And it's mainly because the channel here is very small. There are a lot of boats going through here, so it's ideal to plunder some boats because they cannot really escape very well. And this is an important point, because you might think, well, on the geopolitical landscape, pirates that are basically just part of a national navy, they will engage other naval vessels, big ships, big merchants, but actually these guys, they also attacked the small guys. So this is a herring vessel, and in the Netherlands we used to have a very big industry of herring fishing, but by about 1650, the second half of the 17th century, it was completely wiped out by these pirates or privateers. So much so that Dunkirk was besieged multiple times by multiple nations. This is a famous Battle of Dunkirk where the English and the Dutch teamed up to finally destroy the pirates. They didn't succeed. But anyway, this surely had an impact on the regular person in that day and age. Here you see just a fisherman along the coast. You can imagine that if you completely wipe out an industry, that it's going to have an economic but also an impact just on the available food at the time. So why is this so important? Well, we typically think about pirates as outlaws, but if you really think about it, this was another pirate. They were actually well respected within their societies. They could hold high offices, they could have trusted earnings. So it made piracy a lot easier. Now, if we travel back to our modern days, we still have a geopolitical playing field filled with tensions. We have some actual wars out there, terrible wars, but we also have a lot of geopolitical players who are clearly in opposition with each other, fighting over the same resources, but they're not fighting an actual war. We don't have that many pirates anymore. They're still there, but chances are if you call yourself a pirate, then you're a different kind of pirate. We have to realize that actually maybe we should say that we are still at war. So this is a book. It was published just before the pandemic, and it's called There's a War Going On, but no one can see it. And this is because the current day political playing field no longer is the ocean. They're still important, but what's really important now is the internet. And we've probably all heard the major geopolitical players fighting with each other, having intelligence agencies opening up enormous campaigns of political influencing on social media and stuff like that. So in a way, the war has moved from the ocean into the seas of the internet. But there's a little bit of a catch in thinking in that way, because when you think about states fighting it out, you might think about state actors and intelligence operations, firing off attack after attack, trying to manipulate the people or trying to destroy critical infrastructure. But if you think that way, you might think that you are safe. You might work for a small company. Maybe you think, well, my project isn't really important. Russia or China or the US or whatever geopolitical opponent your country might have is not interested in what I do. You might feel quite safe because you think this will all go over your head. But in fact, we still have privateers these days. So what we see these days is that in this geopolitical landscape, there are independent, private hacking groups that target small businesses with malware, with ransomware, with all sorts of tools, and they are more or less condoned by their own country under the condition that they attack the other side. So just like we had pirates back then, we still have our privateers today. And just like profit back then was enough to attack that small fishing boat just to have a boat or a boatload of herring, these days they can still attack small companies as long as they can extract some money for profit from it. So the current day geopolitical landscape, with all its players, shouldn't make you feel safe as a small player. We really are still engaged in a lot of cyber attacks. And in fact, a Dutch bank just released a press statement, so you have to take it with a grain of salt, 2 weeks ago, that in 2024, 1 in 5 Dutch companies was actually harmed by a cyber attack. Now, they're very opaque about their numbers, so I shouldn't trust them. They probably have some kind of angle here, and they probably want your money as well. But still, a lot of companies are, in this day and age, attacked by cybersecurity. And it's not just the little guy, the big guy, I'm sorry. So all this is to say that you should really care about security. I'm going to now, and I can almost hear you think, what's that? Did you really just tell me that I should care about security? I already care about security. Come on, man, what are you doing? Don't waste my time. I'm here for an interesting talk. Don't tell me what I already know. And I agree with you. If you're here in this room, you probably already care about security. I care about security deeply. I'm not a security expert. I'm just a software engineer and tech lead with a deep interest in security. And I've worked in high security environments and stuff like that. But still, I think that we all care about security. I should have added the popcorn earlier. Anyway, but if you think about it, what is caring about security? I mean, look at myself. I care about the environment. I deeply care about the environment, but I still flew out here. So what is caring about the environment if my actions don't actually line up with my beliefs, right? And it's a bit of an ethical sidestep here, and I'm kind of attacking myself, my own morality here. But what is caring if your actions don't really reflect that care at all? And in fact, this is how the security community looks at developers. So here I got quite a juicy quote for you from a security expert, and it says, "You know how it goes." Oh, sorry. Mention security to your typical developer, and you're likely to be met with an eye roll at best, or puzzlement at worst. Generally, the whole security thing is seen as someone else's problem. Now, this is quite a quote, I have to say. So, do I agree with this quote? Well, I don't know. I think in one way to describe this is that there's always an us versus them in any sort of in-group, out-group situation. I mean, we do it ourselves. Typically, when our applications fail, we say something, oh, it's all about the user. The problem exists between the keyboard and the chair, or we make fun of Java programmers. So there's probably some kind of in-group, out-group bias going on in the security crowd. But this guy is not alone. If you listen to a security conference, if you go to talks there, and I don't mean DEF CON looking at the neat little exploits they have now, which is also really cool, but the security conferences that have to do with enterprise security, they really talk about developers as if they don't care about security, as if you have to work around developers to get your company secure. So we can care about security, but apparently we don't act like it. But I think that is actually an interesting question. Why do developers behave as if they don't care about security? And I think this is a vital question to understand what's going wrong and what we can do better as developers. and what we should do better as developers. And to understand this, I think we have to take a little bit of a sidestep into industrial safety. And there they have a really popular term, and it's called a safety culture. And this is a really important term in industrial safety. And this doesn't just mean trying to sum up how the safety is in a company, but if you have a good safety culture, the entire company believes in the importance of safety, is trying to work towards safety, but, and this is also important, they're also doing risk-benefit analysis. But they're not just skipping the risk analysis in order to get benefits, but they're really conscious about safety. And in fact, this can be really important because if you don't, you can have a company-ending disaster. So this is a chemical company in the Netherlands, and it blew up, as you can see. And what I find quite funny here, there's a Dutch slogan of the company here, and in the slogan they say that they are to be trusted handling chemical products. And I think this is quite to the contrary here. So this company in the accident report had a very bad safety culture. So while they did everything according to regulations, they didn't really take it seriously, and it had an effect on the entire company. So people working at the lowest levels, they might do the checklist, they might not, they really didn't find it important, and then they made a mistake and the entire factory blew up. And this is also what happened here with BP. They had the Deepwater Horizon accident. I hope most of you are old enough to remember it, but they lost nearly half of their value after this accident, and there were even predictions that they were going to go bankrupt just from this accident alone. So a safety culture in industrial safety is really important, but it's not something that just comes about. You really have to care deeply about safety. And in fact, we have something similar in security, and it's called a security culture. And in a security culture, the entire company is aware of how important security is. Not just us developers, not just the security officer, not just the security experts, but also the C-level officers. And this means that you can have a normal conversation about security and do a risk-benefit analysis of adding additional protections to your company. Here, obviously, often it's not a company-ending disaster, but I mean, if you manage to screw up the trust in your main product, I think it can be quite devastating. So I'm not actually sure if on the inside of the company they had a bad security culture. I cannot look within their company. But it's quite a thing as a password manager. You say, trust me, give me all your passwords, and then you have a series of breaches. It's not good for trust. And then there's the University of Maastricht in the Netherlands. They actually had to pay a lot of money to get their data back. The entire research and educational university was shut down for a long time. And this was a very elaborate attack in which the hacking group took about 2 to 3 months to slowly gain access to their entire network and then to shut everything down. This does have a twist. Just 3 months ago, they got their Bitcoin back, and Bitcoin gained a lot of value, so they actually made a profit on the Bitcoin. So it was worth about 3 times as much, but they still say that it was a net loss because they had to spend a lot of money getting everything up and running again. So good security culture is important, the culture in which we as developers are allowed to say, well, you know, we should spend some time fixing the security here. But that's difficult because I don't always get that time. I have a product owner, I have stakeholders. If I say, well, maybe I should go to a conference and learn about security for a few weeks, dive into courses, maybe we should take more time implementing these features and analyzing the security risks, maybe we should hire security experts, then I'm not always getting what I want. So there is something that we can do here as a developer. And this is quite important. So what can you do as a developer? Obviously, you are important for security because you are the one implementing the code that you write, right? So if you make a mistake, if you try to make your own authentication and you create a hole in your application, and obviously you're going to screw up. But I think you have a bigger task. I kind of lost a thread in my story, but I'm just going to roll with it anyway. So I think that you as a developer have a responsibility to be to contribute to the security of your organization. But then what I commonly hear is that, well, in order for us to do that, you have to be a security expert, right? You have to know a lot about security. And this is really a problem, because we live in a world where we developers have to do a lot of stuff in addition to just writing code. And here you have a tweet back from the days where Twitter was actually useful, from Kelsey Hightower. And here he says, well, basically, we can shift everything to the left. We can shift all the responsibilities on developers. But the idea that developers have to become security experts, well, it really just isn't sustainable. Well, I think that you don't have to become a security expert to contribute to security. And I think this is really important. I think that what we should do as developers, what is our professional responsibility, is that we should argue for security. And that is our main thing. So as I am standing here, I'm trying to be an advocate for security. You should be an advocate for security in your organization. We all deal with product owners. We all deal with stakeholders. And in fact, we are all stakeholders in our own code as well. If I make a huge mistake that allows an attacker to cripple the entire system of my company, that makes my application the gateway to a big ransomware attack, do you know who they are going to call? Do you know who they are going to fire, maybe? It's me. So I also have a very big stake in security in my company. So I think that it is our professional responsibility to step up and argue for security, and advocate for security and reason with that product owner. We shouldn't let ourselves be a doormat for delivering features. Obviously, we are not always going to be heard. And if you don't, I'm a consultant, so I can deal with that. Put something in writing. Just write something down, including your arguments. Mail it to your product owner or to a manager. I think that's really important as well. Because if you discuss it over the phone, over a meeting, well, then a year later it never happened. So we should really stand up for security. But in order to do that, we do need to learn a little bit about security. So that is what the rest of the talk is going to focus on, is how can you actually learn enough about security to argue for security. Now, in the tweet you just read, there's an important term, and it's called shift left. And it's fairly simple. In the traditional sense of the word, we were doing security late in the project. So what we were doing is we were developing a project, we were designing a project, implementing it. We were finally ready to ship the project, to put it into production, and then someone said, hey, let's do a pen test. Maybe we should figure out if there are any holes in this project. The problem with that is that it's very expensive. So if you now find some mistake, you have to go back and change your code, which is very difficult, can go wrong. So rather than that, we should shift left the security to earlier in the project and take it into account when designing it. In fact, if you listen to a lot of security experts these days, they say that you have to start left. Because if you shift it left and then stop with your security, you get back into the same project. So what you should do is you should make security a topic throughout your entire software development lifecycle. And if you do that, if you manage to do that well, if you consider security at every point in your software security lifecycle, you should end up with something that looks like this, a fortress, where you have, and this is an important term in security, defense in depth. This is also something that often goes wrong. So if you look at this fortress here, you have an outer wall, you have a moat, you have an inner castle. So if you are an attacker and you want to attack this castle, then you first have to get past the moat, then you have to climb a wall. Maybe there are guards on the wall that will shoot you down, then you have to climb down. Then you're in an open courtyard, but the castle itself is also fortified, so you will still be attacked by archers from here. Then you have to make it past the heavy gates and into the building. So there truly is defense in depth. But if I look at a lot of systems that I encountered, I spend a lot of time hardening the outside. But once we're dealing with applications on the inside, they are not as secure. And those applications, those are typically the applications that allow an attacker to spread their influence. And that is due to something very fundamental in these things. And this is another thing I borrowed from industrial safety. It's the Swiss cheese model. And what it basically says is that we have multiple layers of defense against something bad happening. And in every layer, there are always going to be holes. But it's only when those holes line up that we get all the way through all the layers to a disaster. So what we should do is we should minimize the number of holes that each layer has, and then the chance that all the lines line up to a disaster is as small as possible. In industrial safety, we separate those two things in latent conditions, which we have too, things like outdated packages, zero-day vulnerabilities. They're basically everywhere, and active failures. So we as humans, we make a lot of mistakes. In the the University of Maastricht example, the very first entry point was just a professor who was spearphished to open an email and install something on his computer. So we have to account for this, and we also have to account for the fact that our strong outer layer is riddled with holes, and we really have to do something about that. And that's why security in depth is so important. Even if you're developing an internal tool that's run on the network, you should make sure that it's secure, because maybe that internal tool has access to some other parts of the system that are interesting for the attackers. So once they're in via some route, and they can then hack your tool and use that to jump to another application, you could still be in a lot of trouble. Now, if you want to read more about this, this is a book that I highly recommend. It's by James Reason, the one who came up with that model, and it's also very relevant to security products. So what can you do to prevent holes in your product? Well, for me, there are three basic categories of what we can do as developers that are really easy to do. And the first one is to learn secure design principles. And this is really important and also really easy to do, and then you can just apply it in your work. And the second one is to adopt mature security practices. And this is really fun because you can automate a lot of it. And that's really important. Make security boring for yourself. And the third thing is to know how to mitigate common vulnerabilities. So if we talk about learning secure design principles, what can we do? Now, there are many secure design principles out there, and I'm not going to explain all of them to you because you're much better in just practicing and reading them all, but I do want to highlight a few. And it's, for instance, this one. It's the know unless principle. And this is a really important principle because most of the Python packages that we use don't apply it. And that's an important realization. I'm a big user of web and API frameworks. I've used Django, Flask, Fast API, Bottle, Falcon. I've used a lot of frameworks. And in most frameworks, what happens is if you add a new endpoint and you add it to your router, then your endpoint is accessible to everyone. So rather than being a no unless, it's a yes unless. You have to actively add something to your endpoint to secure it. And it can typically be a decorator to your function. It can be a class a mix-in class that you add to the class list. But if you forget to do that, then suddenly you have an endpoint that's not supposed to be public that is now suddenly public. And in fact, the best example of that I've seen was where a framework had a mix-in with a template method. So you had to implement the template method that actually checked for the security, and then your mix-in class would call the method. What I've seen is that someone made a mistake in the name of that method. And what happened is that the method never was called at all. And the default of that framework was, well, then we'll just allow the user. And they had unit tests for that template method that also contained the typo. So if you really want to code securely, think about the no unless principle. Rather than doing yes unless, always default to no, unless you have something that explicitly gives attention. Now, there are many more of these secure design principles. I would recommend you to learn about those. How can you adopt mature security practices? Well, first of all, I wouldn't invent them myself. I would just look at industry standards, and we have quite a few of those. One that we have is the ISO 27001, which is a standard, and it's important, but it's really abstract. So if I read the standard, I have no idea how to implement it myself, right? But luckily, there are other standards that we can use that are closer to what we're doing. So we have the OWASP, Software Assurance Maturity Model, the OWASP SAM. And by the way, OWASP stands for Open Worldwide Application Security Project, and they have an awesome logo. They're called OWASP, so their logo is an O with a WASP in it. I think it's quite nice. And this framework already has things that make a lot more sense to me, like create a formal definition of the build process so that it becomes consistent and repeatable. So I now already know something. I have to do something with my build process. It has to become consistent and repeatable, nice goals, but how do I do that? Well, for that, there's actually another model, and it's much closer to the doing. It's the OWASP DevSecOps Maturity Model, or DSOM for short. If you find that model, you'll find a principle, and we'll move out of the way, that is pinning of artifacts. And what this means is that if you're using dependencies, like your Python packages, but also your Docker images, and if you're building artifacts yourself, please pin them to specific versions, preferably with hashes. Because now we are way closer to the consistent and repeatable builds that we so need. So, and by the way, I adapted this slide with permission from Timo Pagel, I don't know how to pronounce his name. He is one of the DSOM, the OWASP DSOM project leads from OWASP. And I want to highlight a little bit how the OWASP DevSecOps model works, so you know how to use it for yourself. So that model, which is really close to what we do as developers, has a number of dimensions, like build and deploy, culture and organization. Don't skip that one. I know we're developers, and it sounds really soft skills, but it's really important. And these dimensions, they are split up into multiple sub-dimensions. So here we have the build and deploy dimension. It has sub-dimensions, and one of those is, for instance, patch management. If you look at that model, you will further see that it has some maturity levels. And to reach each maturity level, it has actual practices that you can implement tomorrow in your projects that will make your security better. For instance, here we have nightly builds. If you don't have nightly builds yet with your pipelines, please look into it. Because what often happens is when we're working on an application and we're actively developing it, we're running pipelines all the time, our scanners run all the time. But once an application gets closer to completion, if there's such a thing, then a version of the application might run in production for quite a while. And those pipelines will never run again. And that means that our security scanners will never run again. But there are new vulnerabilities discovered almost every day. So if you implement a nightly build, you get a nightly pipeline that will just rerun the pipeline, and every morning you can simply check, hey, did my security scanner find something new? Now there are way more advanced practices also in here, but a nightly build is really a quick win that you can do in almost every situation. Another one, in the culture and organization one, there's a sub-dimension called design, and I personally think this is the most important thing that you can do, and it's something called threat modeling. So if you think about security culture, the only way you can take a reasoned decision if you know how much risk you are taking. And if you do a threat modeling session, in that case, you analyze your project for the weak spots. And basically, and this is really easy to do. You don't need to be an expert. There are guides online. So if you've never done a threat modeling session for your project, please get some developers together, maybe a security expert from your company, but they're really not needed for this, and do a simple threat modeling session. And this can really help. So if you want to make a change to caching, you know, there are two hard things in computer science: caching, naming things, and off by one errors. So I screwed up that joke. Then you should maybe do a threat modeling session, because otherwise you're going to be Steam. They thought, well, we have a Christmas session coming up. We don't want our systems overloaded. Let's tweak the caching. and they started caching your account details and credit card information and payment details and stuff like that. So if you did a threat modeling session, you would have probably seen that this was potentially dangerous. And maybe you would have implemented tests, like a security unit test, that would verify that the pages that should never be cached are not cached, but because it's quite easy to make mistakes in configuration, especially if you then have to check an entire website for mistakes. Right, now finally, because I'm running out of time, no common vulnerabilities. There are a lot of top 10 lists for APIs, for web applications, for data, and stuff like that. Know them, not because you might encounter them, because it will help you shape the way you think about security. And don't just learn about them, learn how to mitigate them. And preferably, spin up something that allows you to try to find those vulnerabilities in actual live applications. So OWASP has something called Juice Shop, which is an intentionally vulnerable web shop that has many of the vulnerabilities in there that you will find in those lists. Try to find them. It will really teach you something about those vulnerabilities. Don't try to reinvent the wheel. So we all want to do login, right? Don't code it yourself. So if you're doing SQL and you want to avoid SQL injection, don't write your own regex to clean your inputs. Use a framework that does it for you. And the last one, and this is probably the most difficult one, if you do make a mistake. If you've introduced a vulnerability in an application, please share it with your colleagues. Educate them on what you've done, on how you fixed it, because if you don't, someone else is going to make the same mistake 2 months later. For this, you do already need to have a security culture in place, because otherwise there's a blame culture and you might want to hide your mistakes. But if you do one thing, go out there and share it with others. Well, closing remarks, because I know I'm over time. Take it slow. Don't try to do everything at once. If you suddenly implement all the maturity levels from OWASP, and you have a pipeline that you just mandate for the entire company that suddenly has 20 security tools, you're going to get 1 million alerts. And the only thing that you're going to accomplish is that people learn how to ignore all those alerts. So do it slowly, one step at a time. Be pragmatic. Don't strive for perfection. We still have a cost-benefit analysis here. And be vocal. If you care about security, share that message with others. Don't skip the mandatory training of your corporation. Yeah, it's a little bit boring. There's not much in there, but by giving off that kind of mentality, that security is something to be annoyed about, you're not going to get your colleagues on board. So please be vocal about a security culture. And with that, that's it. My name was Sebastian. Thank you very much. You can reach me here and have a great keynote, I guess. Thank you very much.
Thank you, Sebastian. There is a question on Slido, and maybe we have time for one more question from the audience, if you have one. So can you provide some references on design practices for security?
So coming up with references here live is really difficult, because then I have to remember URLs and stuff like that. But what I would do if I were you, if you want to know about secure design principles, if you put that in any a search engine and maybe add software engineering to it, you're going to find a lot of resources. It's not difficult to find. OWASP has a lot of good resources, but they're typically less applied for developers. So they're more about security, less about doing secure coding. But quite honestly, it's not difficult to find. And I'm going to think about compiling a list, so reach out to me on LinkedIn or wherever, and I will share some URLs with you, because that's more difficult to do live.
Okay, thank you. There are some questions in the audience.
You mentioned a few times there's always a balance and trade-off, right? How do you deal with the trade-off? Like, in security, you don't know what you don't know, right? That's where the danger lies. And like, how deep do you want to go? Because you can spend a lot of time and still not know if you're secure or not. So what's your general key for basically on the size of the company, right? How big the danger is, how would you describe this trade-off?
Well, that's actually an excellent question, and this is one of the most difficult questions, but you're probably asking it with a reason. So I think what we can do here is look to industrial safety, and this is kind of where I lost my thread in my explanation earlier. So what you want to do is you want to analyze the threats that you have, and then you want to analyze the probability of the threats, but also the potential consequences of those threats. And the last one is really important because that can help you estimate whether or not it's worth it to spend a lot of time on. So for me, it starts probably with a threat modeling session for an application or a service where you just take a whiteboard, maybe get a couple of stickies out, and you just try to think of what are the kinds of threats that we have in this application and what are the consequences of those threats. What are the risks? What are the financial losses? What's going on there? And that should provide a guide, a framework or guidelines for what's important to you, and then you start prioritizing. It's very difficult to know what you do. Sorry, if you don't know what you don't know, that's very difficult. But you can reason about, well, this is dealing with a lot of customer information. It's a high-value database. Some hacker's probably going to be interested in it, and if it gets leaked, I'm going to get a huge fine, about 10%. I don't know. It's a lot of money, 10% of the revenue or something in a year. Then that's probably something that you want to spend more time on. If there's not much valuable, not so much valuable information in there, well, maybe don't bother. So I would look at that and then compare that.
Okay. Yeah. Okay. Thank you, Sebastian. And I mean, we finished. So thank you.
Yeah. Thank you very much.